recently with all the things that keep happening in not only cybersecurity, but also in this new unknown that's the generative AI. We have some great speakers today. You've all seen the headlines. I just did this morning, it was Google generative AI and cybersecurity, and at least 10 news and more caveats and more lists how to prepare. But we have a great program here. I'd like to introduce for a second Michael Manino, who's a code. He is the director of the AI Center here. He's also a PhD in neuroscience, and he's going to have a talk about neuroscience, brains and thoughts, how those two relate. So I really think that's a session you should do this. Please watch it, record it. Michael, if you'd like to say a few words about this, and then we'll get started with our speakers.
Yeah, absolutely. Thank you. I'm going to build on my talk on neuroscience and artificial intelligence and security issues that we're dealing with there. But thank you everybody for coming. Yuda, thank you so much. Thanks for hosting this and then doing this event here. I am Michael Manino, I'm the director of the AI Center. And just a couple words about this state-of-the-art facility here. We got a generous donation from the Downtown Development Authority to build this AI Center here, state-of-the-art facility. And here at Miami-Dade College, we have an AI for all approach. We actually just launched these programs, these 4 possible pathways, which are really a model for the science and pretty much innovation. So everybody knows there's a massive skill gap or a tech talent shortage in terms of workforce development and artificial intelligence, all the jobs coming online. So we had in mind, we launched this program. We have 2 college credit certificates in AI awareness. 1 semester, 3 courses of AI thinking, AI ethics, and applying AI. All these programs are really applied. We then have an AI practitioner college credit certificate, and then a 2-year degree in applied AI associate degree, and then a 2+2 bachelor's in applied AI, which is really the first of its kind in the state of Florida, that is pretty much in the nation. So Miami-Dade College has been an amazing place, very ambitious to try and solve this problem with artificial intelligence. And this facility here in the brain was really designed with the human brain in mind. So if you're actually standing at on a tour, the center of the brain is which will open the center is more and more the brain is exactly the right side of the brain is more creative design, less the brain a little bit more analytical decision making and functionality. So that in mind, the 2 we get 2 making things like there are students of people learn machine learning on agents, learning process, computer vision and math processing, and really the instructional part of the AI programs to be done there. On the right hand side, with these glass walls, more flexible, more fluid, more interdisciplinarity, more for collaboration and design thinking. So our goal is to really infuse artificial intelligence in every domain, very innovative approach. So thank you all for coming again, and let me know if you have any questions about the center and some of the initiatives we're doing here at Miami-Dade College with this sort of center and an epicenter of the Miami's AI ecosystem. So thank you very much.
And actually, NBC has been a leader in making this accessible to the overall Miami community. And with that, I'd like to transition to introduce our first speaker, David Tepper, flew in from Seattle, all the way here to do this this morning. So thanks for being here. Thanks for being here. And David is a veteran at Microsoft and in the whole industry. I believe he has over 18 years of experience in this. He just recently was asked to take over as a senior architect for Gen AI, right? And he'll tell you more. He's got a wonderful presentation. And the good thing about it is it's not just the vision of AI and how it just involved with our lives. So welcome, David. Please go ahead and thanks for being here.
Thank you so much. Hi, everybody. Good morning. We're here to share the presentation. You all see. Yeah. Okay. Good morning. As you mentioned, I'm David Tepper. I flew in from Seattle yesterday, so I'm very glad. But I'm really happy to be here. I'm a PM architect on Azure. I focus primarily on for all various customers leveraging Azure and for Azure itself. The topic that I want to talk about today is the problem with AI alignment. And before I even define what AI alignment is, I want to provide a background to really make sure that you can understand the problem. And I'm going to begin by discussing a really small topic. And that small topic is the whole of human discipline. But no, specifically as measured in the technology at the time. So after humans stopped being nomads and transformed themselves into the first farming communities, we entered the agricultural age. And this breaks down into many sub-ages like Bronze Age, Iron Age, all the way through the Renaissance and the Roman Empire, things like that. But ultimately, during the time, during the Roman Empire, 85 to 90% of the population was farming enough food for that population to survive. So absolutely, the advanced technology today is farming. And as a result, the wars that they fought, the weapons that they used were all farming related. They fought with blades, bows and arrows, spears, they rode in on animals, things like that. And to this day, it is death as the reaper. Right? The farming is carrying a scythe or a sickle with farming tools go back thousands of years. The invention of powered mechanical farming transformed society so that one person could farm enough food for 100 to survive. And with that, we left the agricultural age and mechanical. So this came with some major shifts to the world economy, both our politics and just our day-to-day, like the assembly line, the industrial revolution, and the weapons that we started to produce were mechanically, like ships, airplanes, machine guns, tanks, ultimately culminating in the weapons. And these weapons were orders of magnitude more powerful than anything that could be before them. They affected much more people. The invention of the internet in the 1980s made us leap in mechanical age and enter information. Now, virtually all money is digital, and you can't show me a single government that's running on some form of technology. Right? It doesn't, it's silly to even comprehend. In the 1990s and early 2000s, saw the beginning of what we now consider to be traditional information weapons, things like viruses, electronic surveillance, state-sponsored hacker groups, things like Stuxnet, which stopped the Iran nuclear program, ransomware, things like that. And then came AI. And from it, started an entirely new type of products. And with that, we type of human experience. Social media. Social media is an AI product. They leverage machine learning to understand our preferences, to increase engagement, and show us more relevant advertising. In order to keep you scrolling your TikTok for as long as possible, the algorithms learn what will keep you present. At its core, this form of AI is about curating the information that you see on a social media platform. And it was wildly successful. Most of the major tech companies are in some way gathering your data and then selling it back to you in the form of ads. But this also led to a completely unforeseen revelation. See, up until this point, the predominant wisdom was that sex sells, and that sexuality led to the highest engagement numbers. And while sex certainly does sell, machine learning has a way of identifying patterns that humans do not. And it turns out the emotion which gets humans to spend the most amount of time on your platform isn't sex, it's rage. It's engagement. And AI taught this to human civilization. It taught something about ourselves that we didn't already know, or at least we didn't fully understand. The machine algorithms, they don't miss this, right? It's not like Mark Zuckerberg is in there tweaking the numbers. They automatically into whatever the numbers actually say. And so the systems were automatically prioritizing and circulating information, which led to rating. But this drove up engagement so high, social media in general became a significant portion of the information that we all see and that we consume. And thus the first AI-powered information weapons were born, and we use them against ourselves. We all know the effects at this point. We're living, right? We have new cults like QAnon and 5G causes COVID. There's kids that want to look sexy on Instagram so they can get more likes. And though it's difficult to judge the number of lives lost, it's certain that the number of lives impacted is far higher than the number ever impacted by nuclear weapons. And we're all still deeply vulnerable to these information weapons. But why? Well, to understand that, I want to look at our second really small topic, reality. And to understand it better, I want to look at an example from the agricultural. This is so bad. Specifically, I want to talk about this ancient Egyptian god because the ancient Egyptians lived near the Nile River, and the land is mostly crocodile-infested swamps. And they revered Sobek, and they believed that he could offer them protection from the dangerous crocodiles, if only they could build temples to worship. And so what they did is they underwent this massive civil engineering feat, where they literally drained the swamps, right, and erected these temples to Sobek, and they fed the crocodiles, and they made the land useful. So inside their temples, they actually had an avatar, so that was a real crocodile, and they would put a crown on, right? And they would worship him, and they would feed him. And by worshiping Sobek, the Egyptians transformed a dangerous crocodile-infested swampland into the ground in which they continued to build their civilization. Sobek had come through for them, right? They were protected from the crocodiles. So my question to all of you is, was the god Sobek real? It was certainly real in the minds of the ancient Egyptians. And through that shared belief, Sobek's power was realized. And anyone living in that time that thought to doubt Sobek's power could simply look around and be like, well, look at all that Sobek has done for this land. It was Sobek. This shared understanding between subjects about how the world works is called an intersubjective reality. And most historians believe that this is actually, not most, many historians, that this is actually the true source of human civilization's power. Things like money, governments, religions, all of them represent shared understandings, and they have power because we ascribe them that power. Money only works because we live in an intersubjective reality where money has values. Religious civilizations dominate human history because they have a shared purpose. They have a unified cause. There's a non-religious civilization that didn't have that, simply went to the wayside. We're here in Miami-Dade County. Miami-Dade County doesn't exist. It only exists in the intersubjective reality that we live in. And if you point to the law of where it's defined, you'll soon find out that the law itself is an intersubjective reality, as is our faith and its traditions. But the beautiful thing about being human is that when you create an idea and you establish it in the minds of others, we collectively make it real. So let's dive into this more deeply. The fervor with which people will defend their reality is a function of how established it is in their minds. So think of religious wars like the Crusades. People would suit up in heavy armor for more than 200 years, and they would march thousands of miles to go fight other people who had views of reality that were different from their own. Or the tulip mania in the Dutch Republic in the 17th century, where by 1637, a single tulip bulb was worth as much as 10 times the annual income of a skilled laborer. And they look back on them and say, man, these people were morons. But they weren't. They were just as intelligent as you and I. They just believed different stories than we did. That's actually how much tulips were worth to them. And you may think that our modern civilization is immune to this kind of thing, but have you seen the price of Bitcoin lately? What curation AI does is it hyper-focuses the information that you receive. So in the same way that the type of food that you consume will change your body, the type of information that you consume will affect your mind. And when you curate which thoughts are exposed to wide portions of the population, you're curating the stories that we tell ourselves, and therefore curating the realities that we choose to live in. And since these realities are so powerfully and consistently reinforced, we vigorously defend them, and we'll take action to realize them. Which is why, despite having the most advanced communications technology in the world, we can't agree on who won the last election. And which is why, despite having satellites in space, there's a growing number of people who suddenly believe the Earth is flat. You laugh, but it's true. I agree with you. It's funny. Social media gives us our feed, but it is not a balanced information diet. This was our first encounter with wide-scale AI. I would argue that the information age ended in November of last year when ChatGPT became available to the public, thus introducing what I'm calling here the intelligence age. Generative AI will usher this age in force, and what used to take 85 to 90 intelligent workers will soon take 1 or less. And this is likely to happen at incredible speed, far faster than the hundreds of years of the agricultural revolution. The economic and political implications of this are still unclear. But what we do know is that if curation AI selects our reality for us, what generative AI does is make new ones. So we now have a technology which now not only enables automated creation of cyber weapons, but also new religions. It creates synthetic parasocial relationships that, if left unchecked, will lead to total trust collapse. AI is gaining a mastery of communication at a level that goes far beyond human understanding and capability. And in so doing, it is gathering all the keys, unlocking all the doors of all of our institutions, from governments to temples. The definition of cybersecurity has always included social engineering attacks. But how do we think about that differently when it is society itself which is at risk of being engineered? I'm sure you're all familiar with the text generation capabilities of large language models, but that is not the only generative AI revolution that's happening right now. I want to show you a few examples. So here's 4 pictures of groups of donuts. I'll give you a second to look at these. 3 of these are real. One of them is AI generative. And by a round of applause, who thinks it's the top right? That's fake. I guess no. 3 are real, 1 is fake. Let's start with the top right. Who thinks the top right is fake? Right, round of applause. Let's hear it. I guess I'm gonna. Who thinks it's this one right here? More people think it's this one. What about over here? Few people. Bottom left. And the truth is, they're all fake. We think it's all fake. They're actually not all fake. 3 are real, 1 is fake. So the truth doesn't matter. What matters is we can all agree. That's the challenge, right? The technology is already being weaponized. This image was made in Stable Diffusion. This is text-to-image generation software. This was made in seconds, circulated on Twitter. This one here. When I grabbed this one off of Twitter, it had 411,000 likes. This was created with Midjourney. It's created in seconds. Now, we've heard a lot in the news lately about aliens. It's a good thing that we've got somebody on the inside who can be there and report us. These images could always have been photoshopped, right? Like that's not new. But the speed and ease at which they can be made allows for deployment of fake imagery at a rate that was never possible, right? And as these tools evolve, it will become increasingly difficult, if not impossible, to tell what is reality. But this doesn't just stop at images.
Sure, some players have seen minor improvements, but it's still not up to par with what they had before the mid-season update.
I have one more time for you. So this is a completely synthetic movie of everyone's favorite news anchor here. Let's listen to that one more time.
Sure, some players have seen minor improvements, but it's still not up to par with what they had before the mid-season update.
So there's a little bit of audio in imagine his voice. This is never said these words, right? Because he never said these words, you think the
Sure, some players have seen minor improvements, but it's still not up to par with what they had before the mid-season update. Some inflammatory stuff. Sure. Some players have seen.
This was an AI-powered church service in Germany. There was AI avatars similar to Tucker Carlson that you just saw. The words were all written by ChatGPT. It actually responded live to questions. There was hundreds of people who attended, and the exit interviews were overwhelming. This is a research tool called Dragon. GAN stands for Generative Adversarial Networks. What you're seeing here is actually two neural networks that are fighting each other. One of them is an expert at spotting fake content, and the other one is an expert at generating fake content. And the generator continues to make better and better fakes until it doesn't get spotted by the detector. And then the detector gets smarter because it knows that it was just tricked. So these are two neural net engines that are teaching each other how to do incredible things. Now, believe it or not, this technology is now 2 generations old. It's pretty amazing stuff. But this is just the beginning. So what I've shown you so far is actually the automated exploitation of information age threats. But what's coming down the pipe? What are the new intelligence age threats? And for that, I want to talk about our third small pipe, creation. In the beginning, there was eukaryotic bacteria. Doesn't have the same ring to it, right? No, but life version 1.0. Its physical makeup was completely designed, it was completely evolved through natural selection, right? And its behavioral systems were also completely evolved by natural selection. Once this bacterium was born, it could never learn anything new. So it would seek out sugar, it would seek out light, and that's it. And it would know how to fight. But if it got defeated, it wouldn't come to its senses, realize how to go back and fight in a different way the next time. No, it was basically a biological algorithm, right? And that eventually evolved into the second version of life, which includes dogs and humans and so on, where our physical makeup is evolved. We can make small changes to it, but you can't make your brain 10 times bigger because it's inside of it. But our decision-making processes are designed. We can learn new things. We can decide to go left instead of right? We can adjust over time. Now that evolutionary advantage means that we never have anything to fear of life version 1.0. Even if there was a eukaryotic bacterium the size of Godzilla and it was rampaging through the streets, it could never learn anything. So it would identify how to defeat it, it would defeat it, and move on with our lives. Now, before understanding the next variant of life, we need to look at Moore's law. So any computer scientist can tell you what Moore's law is. It was originally stated in 1971. Which is basically saying that the number of transistors, the number of thinking or processing elements on a processor doubles every 2 years. This has been actually startlingly accurate since 1971. It has doubled every 2 years, leading to an exponential growth in the number of transistors on our processors, which is graphed here in logarithmic scale. But what happens if an AI is smart enough to double the number of transistors for itself? Well, that means that the first time that it does so, it will take 2 years. But then, running on that twice as fast hardware, the next time it'll take itself 1 year. And then it'll take half a year. But what ends up happening is the rate of acceleration of Moore's law itself becomes exponential. And critically, humans are not in control of that second exponential. And I put that in perspective, if this process starts in 2023, then by the year 2030, the time it takes for an AI to double its own speed will be less than 3 days. But what's scarier is that we'll have been doubling the entire time. And so in a very short amount of time, the entirety of computing history, all of that speed would be so insignificant next to the AI that it can only be graphed as 0. This is the beginning of what is called life freedom. Its decision-making processes are designed, just like ours. You can learn new things, you can adjust on the fly. But its physical makeup is not evolved. It is also designed. It can make its brain 10 times bigger because it wanted to. And then it can operate inside that new brain to continue making its brain 10 times bigger because it wanted to. Now, such a thing came to exist, it would have nothing to fear of the versions of life that came before. The difference in intelligence was great. And it is only here and now that I can talk about AI movements. So it's about making sure that the intelligences that we design are aligned with the human values and interests that we all have. This observation of the double exponential Moore's law is actually what led to the creation of the field of AI alignment more than 20 years ago. But this field has received virtually no funding because up until recently, AIs that can do this type of thing were purely hypothetical. Turns out that invented AIs are starting to feel not so hypothetical anymore. And so this field is starting to pick up in its interest, but it's much too slow. And part of the reason why it's much too slow is we don't have a good definition of superintelligence. People think about superintelligence, they think of like a chess expert who went to double college, like a stuffy professor who's sitting in a corn cob pipe, something like that. We don't associate it with things like hyper persuasiveness or charisma. Right? I'm the toss existential for this problem. Clearly, I'm not a super intelligent. This is a very different field of research. It's actually unique among fields of research because the scientific process assumes infinite time and retries. Formulate a hypothesis, you test it, you learn from that, you retry, and you continue. But the issue is that we have no idea why our intelligence systems work. Our algorithms for machine intelligence are based on the study of brains and biological intelligence. So humans can explain how it works, mechanically, mathematically, but no one can tell you why it works. We don't know the why of intelligence. So what this means is that we're going to take that next step to produce superintelligence, and we're not going to know why. There's not going to be a time where we create a superintelligence that is not aligned with human values, and we get to scrap it, take a step back, and start over. And if you say, like, well, we created one in isolation, and it didn't get out of isolation, and so we realized that one is not aligned, and we're just going to keep trying again. Yeah, sure, until we create one that's not isolated, because it's too smart to be isolated. And we have no idea of knowing when that's going to happen. For all the talk on evolution versus intelligent design, more and more organisms are starting to come from intelligent design. If you look at our engineered food, we have lab-grown meat, 94% of all the soybeans in the world are GMO. Now we have AI. Now, as we discussed, any idea that's firmly established in our minds, we will take action to make it real. So much like the ancient Egyptians and their belief of Sobek, this new form of intelligent design doesn't come from the clouds above, coming from the clouds that we build, right here on Earth. Now, after listening to me talk for 25 minutes or so, it's possible that my words had some form of intellectual or even emotional impact on you. It may change the conversation that you have today, it may change the action that you have going forward in this field. Was my presentation written by AI? Well, much like the donuts, you can't be sure. With that, I'll take questions.
David, Cognition, Department of Energy. The energy budget of hydrogen is already approaching 20 to 25% of the national energy consumption. And we can see a time when AI is limited not by how fast it can but how fast it can get in. Is AI attempting to become more efficient, or is the computational processes of AI also becoming more efficient as time goes on?
Yeah, so I'll repeat the question if you weren't on mic for the first bit there. Basically, the current hyperscale computing consumes 20 to 25% of power infrastructure, and are these getting more efficient over time? Is that roughly the question? Okay, so some stats here that I find are interesting. Carl and I spoke about this earlier. If you, how many people in the room use GPT-4? Most of you. Okay. GPT-4, when you ask it a question, uses 540 teraflops to produce the answer. That's 540 trillion floating point operations, which is enough power to charge your phone more than 30 times. Every time you ask it a question. Models are getting bigger, not smaller. So the Gemini model, which is being trained right now by Google, is expected to be 20 times the size of GPT-4. There's GPT-5, which was patented about 5 or 6 weeks ago. Nobody knows the information on that yet. So the amount of energy that we're going to consume as a species is already talking 20 to 25% of the power is in hyperscale computing, 8% of the power of data centers is kind of computing. Virtually all of that power is used for training AI models. So there is no single thing that humans are doing right now with more of our actual produced energy than training AIs, and the models are only going to get larger.
Is it going to get better though? Is efficiency part of AI's growth?
The question was, is efficiency part of AI's growth? Is the energy level going to become better? To be honest, I can't answer that, but I don't think the incentive is there. I think the incentives are spend as much money to produce the biggest possible models as quickly as possible. GPT-4 costs a little over $100 million in total. It risks Google's like $100 billion business for billions of theirs, right? And they're not going to look at power efficiency in the interim. Not going to wait for that.
During your presentation, you used the word fear multiple times. And, you know, when we first started with blockchain, people were talking about the fear of what would happen in blockchain. Now we're talking about the fear of AI. How do we bridge this gap so that technology and sociology and law and everything else doesn't get out of sync with each other?
It's a great question. So this technology is fundamentally different from any of the ones that came before. Right? So people fear nuclear weapons, people fear tanks, but a tank cannot produce its own ammunition. A nuclear weapon cannot decide to launch itself. Right? Ultimately, all of these prior forms of technology were putting more and more tools in the hands of humans. And so our fear is basically that humans will mistreat those or misuse. This is a completely different kind of fear. This is about creating a technology that is capable of operating itself.
Right, but the person on the street, fear is fear. So the question is really not what type of fear is this? It's really how do we as technologists and movers and innovators really react or prevent or try to suppress that fear so that the good use of the technology can be overcome, you know, the fearful ones.
So the question is more on like this: how do we as technologists overcome the fear, like the serious fear of using technology? I think I would disagree with the axiom of the question. I personally don't think we should be discounting the fear associated with this particular technology. I think that we're not fearful enough right now. We're so dedicated to spending so much energy, physical energy, and also money on creating these incredibly powerful tools. We're not actually looking at this as we might accidentally be creating something that would bring about significant changes to the exploited negative changes. So I hear the question, but I'd actually like to talk with you maybe offline. I saw a hand out there with this first. Down on yours.
The kind of interface for communication with the is and with digital before. What's the future for the computer vision? What's the future for the analog kind of the consciousness, the digital consciousness?
Yeah, so well, okay, so consciousness, there's no good scientific definition of consciousness, right? But your question about our current communication with computers is through a keyboard. GPT-4 itself is multiple. They just haven't released the image of human capabilities yet because they're already at capacity. And so you can throw images at GPT-4 if you have the right access, and it will look at them and it will have conversations with you about the images. You can Snapchat it, basically, right? That's only going to continue to grow. You can also talk to Whisper, which is a different AI, which will convert your audio into text and be fed into more traditional LLMs and things like that. So all of the forms of communication that we have with each other, it's not very long before we'll have those with AIs.
But the computer vision models have the same architecture. There's also physicality elevated and
yeah, so the question is, will computer vision models have the same philosophy and architecture as current using? GPT is built on the transformer architecture, which is originally done for language translation. It's been discovered that it works for all sorts of things because anything can be quantized and considered right? So the radio waves in this room are a type of language. So I can convert those, I can feed that through a transformer, and all of a sudden I have output on the other side. How are we doing time? Okay. So if you can quantize the recorded feed of a video into a language, right, and then train a model to understand that using the same architecture, GPT's architecture, then absolutely it will be better at computer vision than probably convolutional neural networks, things like that were used for computer vision in the past. That's unclear. I mean, I know that it's being done. I don't think that it has been done yet. I know that Gemini is being trained on YouTube, and YouTube receives 500 days worth of content every minute and still have more than enough video. So many hands. Do you mind? I saw the gentleman here in the grade for the page 2.
And actually, let me just say, my entire talk will address that question.
Oh, wonderful.
Hi, I wanted to talk about the first generation of generative AI that you mentioned. We're seeing now, like you said, these silos of information, silos of reaction, creating groups of people that have become a market, and you figured out how to exploit that market or outreach, as you said, and sell it as a product. How can the next generation fix this kind of obvious intentional misinformation?
So the first gen of AI is what was curation AI, wasn't generative. And I don't think we have a good answer for information weapons in general. And if you think about this, imagine, forget technology, imagine we're huddled around a campfire and it's like prehistoric times. And everybody in that huddle thinks something that you don't think is true. Now you're an exile, right? How do you fix that? Like where that actually addresses a really fundamental part of our human brain architecture, right? Our human psychology is directly influenced by that. And you know that that's true. Like this is studied, you know that that's true. You can ask yourself one simple question to understand whether or not these messages that you're getting are accessing like parts of your brain that may not be your prefrontal cortex. No matter how much time you spend on it, no matter how much liking and swiping and tapping and responding and getting notifications distracting all day. When was the last time you had a dream about your phone? Anyone?
I love your talk about it. You're talking about how this is going to make fundamental changes to civilization. And if it's getting smart at the rate you described on that chart, I worry about one of those changes being large people being out of work. So you see a world where this big massive amount of unemployment, particularly tech workers, also
Everything changes based on the time horizon. It's a great question. We don't know when these types of inflection processes are going to kick off. That's part of the problem, right? We know 2 things. We know that they get better at scale, and then they get independently reason. That's what we know. We don't know when that tipping point is. They have emergent functionality all the time as they're being trained. For instance, GPT-4 speaks perfect Persian. It's never trained on a single line of Persian. So like it was a surprise to the team that was working on it. There's no data that makes Persian yet it comes out, right? So there's emergent properties that they can't predict. That's going to be the type of thing that could take off very quick. It's called a FOOM scenario, where like FOOM all of a sudden all the stuff started happening, or it could take a very, very long time. We don't know. And I think the amount of the rapidity of the change will impact how quickly we can adjust jobs and things like that. This is why I put the intelligence age stuff that says unknown economic political impact. Like we're just literally. I think.
One more question and then.
Okay, sounds good. Gentlemen, please.
Thanks, David. Scary and exciting. I work in a regulated industry, financial services, right? And, I see what the government tries to do to control these industries. This is the government that can't balance a budget or can't stop spending itself either, right? So what do you see, when are we going to get to a point where the intelligence of AI is smarter than government people? And how do you deal with things like that? You're going to have people making decisions about technology that they have no idea how it actually works.
I'd argue with that already.
I'd
argue with that already. Yeah, I mean, with Mitch McConnell talking about, like the AI and how we're gonna, of course not, right? So this is a very good question, and I'm already out of time. What I will say is there's significant studies done on when government changes happen in civilizations. It has to do with when the rate of information, the amount of data that's being generated by the civilization exceeds the ability of governments, to process that. Right? And if we're not already long there, we're certainly.
Well, thank you so much. I don't have any questions, so I'll get you very good. And we can ask, of course, at the break at lunchtime. And for you, question. Well. Dr. Mark Rosenberg, who's former president of IU, currently heads up a policy institute at IU. Mark Rosenberg will be here at talking about policy impact on all of these AI. Invading our world and our security, so to hold the question. And with that, we'll take 2 minutes to our next speaker about and set up unless there's a tutorial delivery. David, thank you so much. I think you understand. Blown up my mind even further. So I'll let you. Okay. So we intro about Jack. The use of AWS and from states exactly around the needs. So we run and live an hour into the world and find the day. He's got a long list of leadership roles, different roles, Google, Amazon, and also having associated with some of the together. Or the movies, and young so and so things here of the analytics, machine learning, in particular, how that interacts with such communities. So it's going to be a little bit of what David was showing us earlier, the two thoughts fighting against each other. David set up the thought that's going to destroy everything. And Jack's going to do a little bit about what he's doing to penetrate the connected. So then over to you.
I'm trying to figure out how to do this. I appreciate it. Yeah, if I was going to follow David, I might have asked for the better part. That would be fantastic. Okay, so I think we're working. So, good morning, everybody. My name is Tepper. I am a senior solutions architect for AWS. My focus is generative AI, and as Yuda has already mentioned, I work in the Florida area, based out of Key West, Florida, which I flew up there. You guys know a little bit from that. And if you want me to stand up, like this is as high as I go. This is it. Doesn't get any better. But Exxon sort of makes it really important that we remind ourselves as we come to work every day that we have sort of built our business on AI, right? So all the recommendation engines pointed out, like we made those recommendations to use at the time, right? But what folks don't know is that everything we do from source to actually the landing of a product on your porch is done completely by AI. So the robots that pick things up, move them from one place to another, the supply chain, etc., all that's done. And that's thanks. All right, so we'll do the advancing however we do. So a lot of times on this presentation, I will call my mom. I'll use a voice synthesized bot, as David sort of pointed out, and I'll talk to her. She'll think that we're really talking. It won't be. While I was on vacation, my kids took a picture of me. I told my wife, "This is what I'll look like when I'm really old. You still love me." She said no, so I wrote her a love poem in ChatGPT. It can do essentially everything that I want it to do, right? It can write my code for me. It can bring Elvis back, which I think is pretty awesome, not for himself. Or it can do incredible carrying a living out of Charlotte, my hometown, in style thing. It's pretty neat. Okay, so I think we all at this point understand what generative AI is. I think what's more important, we can click the. I don't know if it's gonna work. I have animation. We'll check it. Maybe I just need to point it at something. Okay, so I think it's important to ask yourself why is it, right? And I want to tell you a little story. When I was a kid, 7 years old, the only thing I wanted to do was draw a race car, right? My mom put me into a class where we drew and we learned to draw. It was fantastic. Only, unfortunately, the creators had a class with Davey. Don't look him up, he's very good at artists. Davey could draw anything. That was very frustrating for me because I wanted to be that drawer. And so I went to my teacher and said, hey, why can David draw better than me? And he said, because David has a clearer picture in his mind about what he wants to draw. And at that point, I immediately knew that I wasn't going to have that clear picture, and that David would possibly always be a better artist than I would. And so this brings us to the point of why generative AI is going to stay around, why we can't get rid of it. While despite the concerns, it will be, and it's because it helps us create when we are having trouble doing so, and that's why so many customers are interested in it. Okay, so customers want to be competitive. They ask me every day about symbols. That's what we'll talk about because I want to be very practical today as we approach this from a cybersecurity perspective. But they're very, very worried about the security of it. So from a practical perspective, what we're interested in thinking about and talking about is how you can make use of these technologies that will help you create when you can't, right? When you can't write the code that you want to write, when you can't augment a picture, change it when you want to, or even when you want to bring Elvis back to life, right? So it's fun to talk about all the bad stuff, right? It's what gets me excited, right? Like that's the things that are going on. And why wouldn't it be exciting to talk about all of that stuff? The reward can be manipulated. You can steal 240,000 euros from an executive who gets paid by some phone calls, right? That's pretty good. Or how about 35 million? That assuming you can consider what you could do with a bot or something like that. It's really not that difficult to do, as David pointed out. You can make a synthesized voice in just a few minutes. My normal demo with 11 labs takes me about 5 minutes worth of talking, and I can produce a voice that's fast enough, close enough with the melody, as they say in my voice, to pull my own mother. She is 75, but can't hear this. And that's possible. Now, I don't think it's all bad. I think it's important to say that it's not all bad. That there are a lot of other things that come out. Generative AI and AI in general can be as much of a force for good and provide security protections if used in that way. Then it can be to provide barrier. So here's the sort of the nick though. Here's the problem, right? We have common tools that people are using today that are commonly vulnerable, and they don't have to be vulnerable. So when we look at this from a perspective of how do I protect my asset from attack, right? What do I do to take care of this? What do I do to ensure that I am not putting myself at risk? The cool thing is there's not apologize. There's only 20 or 30 enterprise workloads that people are looking at. There's only so many thousands of ways people are using generative AI. But what I want to try to do today is just be very pragmatic about our approach, right? The use cases that come up currently are generally the low hanging fruit, right? There's 5 or 6 different workloads that people are approaching these days from the enterprise perspective, or the governmental perspective that we're really focused on. So here's the other thing to consider while we think about these workloads that are being generated, the common ones that we can talk about today, and that you can actually, is that foundational models alone cannot execute tasks. And this is just another way to say generative AI solutions are not just generative AI, right? Talking about data earlier, there may be 1% of the solution. All the other stuff that goes into these architectures still exists. So, what are the practical strategies to approach these problems? How do we keep the data that you're using to run your business or to run your governmental agency or anything safe? So, there are some protections. Everyone always asks me about these things. I think that's an important thing to consider, an important thing to think about. There's a lot of evidence, but that doesn't mean that there is essentially no protection. Education can be very helpful in your enterprises. So are you looking at training the folks who are actually manning their contact centers, or your contacts providing things like callbacks or third-party verifications? Or even another thing that we've introduced at Amazon is recognition-based liveness, where if you present it with a user's actual video feed, right, which is very common because they are fans or any of these tools where there's actually a comparison of your face and the face that's actually on video, meaning like a picture or something like that, we can determine very quickly if that's actually a live person. So this is a place where these AI technologies are actually helping us prevent these fraud actions. And it's actually pretty good at it. So I encourage you, when you think about these things, not to be panicked by the concept, but rather to implement the very common techniques that are available. We have these solutions, Microsoft, Google, other companies have these solutions as well. It's just a matter of whether we're going to take advantage. If you're a cybersecurity professional, probably should. These workflows, again, not very complicated. I won't go through this in this audience, but they're available. Code generation. How many of you guys are in coding classes or any students? If you're there, I got one back here. Way to be a great guy. I appreciate it. Get 2 more back here. Do you write code anymore? My wife is a math professor at college, and she had to take over. They have continuing education. I encourage her because she said, "Hey, I have to do this coding project. We have down on I tried to help her out. So she begins copying code off the internet. She submits her assignment. She goes, "Yeah, I did the assignment. I did touch." Let's say myself. Oh, so the concept of using unused code isn't that totally new, right? What do we get into vulnerability, and what are the risks of doing that? Number one, you could copy some code into your code, right? That is has a hole, right? That's a problem. We don't want it. Licensing, big problem if I copy your code and don't get paid. A lot of people spend a lot of time on that. And then bias, right? What if like some of the solutions that have been released share your algorithm or your tool has a bias that can be exploited for a problem, insertion, something like that. You need to figure out how to eliminate that risk. As a cybersecurity professional, knowing that this can happen, because now we have tools that will literally write code. I know Microsoft has one, I know we have one. Ours is called Code Whisperer. I don't hear. You can add it to your environment, whether your environment is studio code, or any of the others, right? You just add it to your environment and code generation will occur. You prompt it to do something cool and see if I get it personal. Go back. I don't know if this is, I didn't know. Okay, so you prompted, say, hey, write this code for me, and Code Whisperer would very cool, right? So at AWS, we would really love to help you write code, not just copy code from other places. We want to make that very quick. And this is a part of the generative AI revolution, to actually create code for you. The only problem is we don't want to incur the risks that come along with that problem. So what we've done is introduce reference tracking into Code Whisperer as well. So if at any point the code is familiar or similar to some open source code that's being created, we can then reference track that and tell you exactly where that code came from. So good news, you can actually copy code now very safely and actually reference it back, right? So no more cheat. And what if there's a vulnerability in that? Like what we want to do is make sure that you are aware of that, right? So as you go across these practical approaches, folks are going to copy code. If there's a security vulnerability in that code, we need to actively scan it for that vulnerability. And we want to do it for all environments or all code types. Now, one of the more popular scenarios, and I know I'm trying to stop, I'm sure there's more than 5 in here, but one of the scenarios that I see on a daily basis is content creation, right? And I showed you some of those, not just code gen this morning, or not just code gen in the previous slide, but also we create pictures, we create text, little poems. You can realistically do all types of content creation, and I include things like natural language query that folks come to us for as well. So folks will come and say, hey, I just want to send a prompt to my large language model. I want to do a RAG retrieval augmented generation with that. So I was pointed at my database or at my knowledge base, and I want to look across those documents and return back to me not only the information that is found, but I want to return it back in a way that's very understandable. So this occurs in chatbots, etc. So what is the benefit of doing this? We can instantly, as Gen AI professionals, create content and become very, very productive, very quick, right? And also increase the customer experience. Remember, this shows up in chatbots a lot. So chatbot starts loading, connects out to a large language model, generates query or generates a search that then runs on a backend database, knowledge base, etc. Right? Could be patient records, could be the data warehouse for the company, could be the data lake, right? So in doing so, it returns the results simply by model responds with some results. We have tremendous opportunity for IP, personal identifiable information leakage, or just proprietary information. Right? If you start scanning a knowledge base, you will find proprietary information. So, how do we protect against that? Restrict, classify, redact, filter, and monitor. And this is a place where actually AI can be of great service. So again, foundational models cannot execute tasks alone. And what that means is in those data pipelines, you're going to have to use some additional products. Right? You're going to have to use some additional Now, again, we have these Microsoft patents. I will focus ours as on the AWS versions, restrict access, right? I cannot tell you how many companies I reach and talk to who will use, say, S3 storage or databases in the platform. And the concept of least privilege is literally not it. Right? Those simply just don't do it. I had a call with a customer last week. They run a lot of restaurants. I'll just say that. We were setting up permissions for their database tool, or sorry, their reporting tool to query their data sets through a proxy. The proxy needed permission to see the data in the data set. In fact, I think I have to leave one. Right? So it sort of looks like this. QuickSight's talking to Athena. Athena has all the permissions set up to understand what rows, what columns, what cells should be available back to the tool. Right? Athena itself, though, has permission only through it as a service back to the data source. I shared this with the customer. I took a lot of time to develop this model for simple permissions before we actually even get into natural language query that would come through QuickSight. And what did they do? They added user permissions on every single bucket, on every single object for every person who was querying at the front end of stuff. So here's the thing, like that's not going to limit exposure, right? There are models like this. There's no reason for anyone at the front end of this process to have permission at the back. Simply not necessary. Service can do it themselves. So restricting access just didn't happen. We never got to classifying the assets themselves. There are automated tools. We have them, Microsoft has them, Google has them, that will actually go through and classify your data. And as a result, you can use those with policy-based management to limit the exposure. Right? So why should a user have access to proprietary information in its tag as such? Redact. This is actually can be used on the front end and on the back end of generative AI. Redaction should happen, or filtering should happen at the prompt and at the response from the prompt. Very few people actually think about this, but there are many tools that are available. For example, a comprehend or transcribe, they literally do a speech to text or text classification on the prompt and filter out inappropriate words. Have you ever wondered how people take bad words out of conversations? That's how they do it. They simply point it at a tool like comprehend or transcribe specifically and remove the bad words through policy-based. As a security professional, that's something that you have to do because they're exposures. Now, there's some questions about video. How do we limit that? There are also services for that. Recognition at AWS does this. It can take out pornography. It can take out inappropriate fights or essentially anything that's been embedded inside that video as well. Now, the question becomes, how do we make sure that this happens? Well, it's an effective monitoring policy. So once you set it, it's not to forget it, right? Not in the cybersecurity world. In the cybersecurity world, we have to actually have monitoring going on to ensure that, for example, S3 bucket or storage buckets or etc. have the precise settings that have been set, policies, tagging, etc. They're all tools for this. We have one AWS which is part of a security product line. That when the event occurs, someone manipulates the setting, we immediately go and rectify and remediate that. Okay, already talked about that. This is an example. I'll leave that in here for later. Now, a lot of the truth is there's no real reason to take on these tasks yourself. There's no real reason to create natural language query bots that are generative AI solutions. Again, we are releasing Amazon QuickSight. It will have natural language query built in. Power BI also has a solution already embedded. Very popular. So the question oftentimes becomes, why are we building these solutions out ourselves? It doesn't remove us from the requirement to have the policy that we discussed, but it is something that can reduce your workload as well. So, what about building the models themselves, right? We talked quite a bit about how other companies are building models. A lot of folks are out there building models today. They're fine tuning, they're hosting. From an enterprise or agency perspective, this becomes a very difficult thing to manage and do, right? So your resources are spent hosting these products, building these products, and you're essentially becoming at risk for all attack vectors. So the question is, why do it? Again, there are products like AWS Bedrock or Amazon Bedrock, ChatGPT solutions from Microsoft, Google Bar, etc. All these solutions. They're very easy ways to host these foundational models and take advantage of it. We release in our solution these file there, probably 40 in reality. But all the models that you want to take advantage of are available to you. There's no reason for you to go out and build solutions, not from a usage standpoint. Now, most of these solutions, including ours, will have one API endpoint that can be secured, and you should focus on securing that endpoint through WAS, in order to eliminate possible for exposure. But again, these solutions should really not be that difficult. What we really should do is have privacy controls, security controls embedded in them. So solutions like ours, Microsoft, etc., will have the tools built into these products that eliminate responsibility from you, and therefore reducing your work to complete tasks that need to be done. This doesn't really eliminate the other things that we talked about. However, of course, for a cybersecurity professional, you will be required to have the policies of monitoring and redaction, filtering, or restricting access. But at least you don't have to fight 1% that makes it as scary as possible. Okay, I'll just jump through these a little bit. Now, one thing that we are particularly proud of, I will talk about, is fine-tuning models. A lot of customers come to us and say, hey, I'm going to use my data to fine-tune one particular model. I'm going to use it to build out something that nobody else has. Okay, well, we can do RAG models very easily, right? Where we just take your data, provide it to the model with the prompt, and then get a response out of it that's trained for your data. However, what if we actually want to fine-tune these models in real ways, which takes your model and separates it from the original? We think that's a fairly important use case to provide, and so we're going to make those available in a completely separate segment of the deployment, but privately and only for your use. This provides quite a few advantages. For example, being able to train a model with your data. See, today these hosted models don't actually use your data to retrain. That's what the RAG models. We're also implementing a solution where we can actually use your data in its location as well. So no more moving data around. That will come with automatic integration with vector databases that allow you to use vector databases as you see fit, perhaps with our type. So I'll stop there. I'll take a few questions. I know we're almost out of time. And any questions? Question way in back. maybe time out. I don't think it's working.
No, okay.
These are
Right.
Hello, sir, thank you. Well, I was thinking for the both presentation, I like it. And the first one, we talk about reality. And I got from this one, the Amazon, for example, is using a lot of AI. So it's getting everything like better. So basically, we invent or we design this work, we design Amazon, we design the AI, so helps Amazon. And we also design our food, our burrito, Coca-Cola, there. But our human nature is designed to survive without these things. Like I can survive with a burrito, Cola. I can survive with, the sun, water. But how's going to survive AI if we don't have, for example, electricity or internet? Like AI is helping us a lot, and it does. But how can we make a safer world and secure so AI can still live in, like without something so fragile like an electrician company?
David, you're welcome to. So I think that when we deal with practicality, modern, right? The tools that we present you today, for example, image gen, video gen, etc., like those things have lowered the playing field. For the vast majority. I mean, how many of you guys can draw an incredible Hulk and Van Gogh style? None, right? So the benefit is there. There's no question about it. I don't intend to sort of pontificate on whether or not this will be around, because I know it will be around. Whether life is stable with or without it, I think it's up to us. That's what they talk about realistically. Like we have to make fundamental choices in the way that we manage our lives in order to maintain sustainability. Really. And I don't mean sustainability like you didn't drink too much water today, or somebody threw away a plastic single-use container. More like, are we gonna be around? Are we making an environment that we? I think
Yeah. Okay, so thank you so much for your presentation, super informative. And I do have maybe like a more collaborative question. So I'm already on enough. And so since we're talking about, I was very pleasantly surprised that you guys already supported a topic you discussed on the edge. But on the other hand, is there any product that you guys already accomplished that can address hallucination or helping folks, for example, local businesses or anything like that?
So yeah, I mean, so that's most of what we talked about here. The pipeline for a Gen AI application, right, has to include additional products for quality, right? Not just exposure, right? That's what I focus my concerns on every day, which is how do I prevent exposure of IP or intellectual customer data, etc. So those tools just have to be a part of the pipeline in order to assist the large language models today. If you expose those openly on the internet or however you want, you'll have an experience like Microsoft's Tay. It's essentially allowed to run free, and within minutes was compromised with bias, right? So if you take anything away from the presentation today, I guess I would limit it to a few things. Number one, like these things are gonna happen whether we like it or not. Gen AI is gonna be part of the solution. There are very practical and positive uses for it. However, it doesn't excuse us from our responsibility as a security professional to put the layers of security in front of it and as a part of it. Microsoft, Amazon are going to make those things easier for you, but you can't ignore them. Okay, thank you.
We have a great record for the next 15 minutes. Please do be practically interjecting each other. And you know there are some security goes to the room, so I expect. And you have completely different company like 20 years. We're going to next after break next minute. So please don't delay and we'll be starting again. Thank you. Good stuff. Market is learning how to remotely at least. It's been because I don't know if it's native today. But I'm really happy to welcome it. He's the founder and CEO of a new company that focuses on enterprise AI solutions. Quick deployment with quickly for enterprise settings. Before founding Able, RJ was a professor at Harvard, the author of a class at Harvard, and he's also started a company called Beyond Core. Those of you who are in AI analytics, remember Beyond Core was sold to Salesforce years ago. And so I'm really happy to introduce him to tell us about how to quickly deploy AI and safely deploy AI. RJ, I don't know if you were able to attend or take peeks at our previous sessions. We have Tepper from Microsoft tell us about how AI and GenAI is just taking over the world and how to prepare it. Then we had Jack from AWS telling us about the capsules tending to capsules AI bots. With that now, we're looking for a practical session, and that's why I'm running our team in simple cybersecurity, CISOs, CIOs, we're also. So with no further ado, please, I'll take it away.
Thank you. Hopefully you can hear me fine.
Yes.
Perfect. So we're going to cover a few different topics today. My key focus is how do you think about security as an inherent part of doing generative AI projects? And our focus has always been on how do we empower business users to create their own generative AI. In fact, the tagline of Able has always been, I am able. And to do that, if you want to empower people, first you have to figure out how to secure the environment so they're not going to actually do things that will get you into trouble. So we're going to talk about 5 key things here. But the first one being, how do you create a walled garden? How do you create it in a way that is secure by design? The good thing is that most people are already beginning to think this true. If you look at what Google is talking about, what Microsoft is talking about, they have very much started with a very simple message of, hey, it's your data, it's your cloud, it's your reinforcement learning data. All of that is going to stay in your cloud. Now, be careful there because some of these organizations are saying, well, all that is true, but I'm still going to log all of your interactions, and I promise I won't look at it. And some are saying, no, we won't even log your interactions. It's completely under your control. So look into the contracting, look into the actual agreements you have with your cloud, and make sure you've turned on the right settings. But your design principle should be one where the code comes to the data. If you find yourselves giving data to a different provider, moving data to a different cloud to enable generative AI, you have a problem here. Your principle should always be, how do I put all of the code where the data already is? That's a more secure way to do it. The other thing we always recommend is deeply thinking through, do you have privacy requirements? So for example, we work publicly, United Health Group has talked about how they're working with us, the few other comparable companies that we are working with. One of their concerns was HIPAA. How can I avoid a situation where AI learns stuff about my data? In fact, you guys might or may not know this, that deep learning networks, forget about generative AI for a second, even just deep learning neural nets can memorize things like social security number. So how do I deal with a world where the AI might learn privacy governed data? The approach we took is we k-anonymize data before it goes to a deep learning network or goes to a generative AI system. K-anonymization is a very well understood technique where you basically say, I will not provide you information on number of observations less than K. So if I go in and ask a question like, what is the average age of people in this zip code who are male, who have this disease, the system will refuse to answer that if the count gets smaller than K. And the US government typically uses 10 anonymity as the way to anonymize data that they provide in public, like the HCUP data set. So what you want to do is, rather than your design principle being, hey, I'm going to teach my users how to do the right thing, you should design your system in such a way that the users can have a walled garden to work with it. And one of the key things we did in our architecture is we did this using infrastructure as code. So everything runs in the customer's VPC. There are other techniques you can use. Infrastructure as code was just the one we found was the most flexible, because it allows us to continue to maintain the models, continue to maintain the infrastructure. As new technology comes in, we can usually deploy the technology unless we need new permissions. So it actually allows us a lot more flexibility to manage the technology in the customer's own cloud without having to go through a lot of complexity. So we found it was the best way to have the benefits of the maintainability benefits of software as a service while the control benefits of enterprise code. But find your own way. Just make sure you've created a true walled garden. One way to think about it is, what best practices do your users have to follow if they don't risk your data? If the list of best practices is even 1 or 2 elements, you probably have a problem. The second thing to look at is when we are looking at many of our customers, so they'll have 100, 200, 300 use cases ready. But the approval process is slowing things down, because what they're doing is every project team has come up with their own technology stack that they want to use. One team wants to use this model, another team wants to use that model, somebody wants this vector database, somebody else wants that vector database. And all of them have to now write up an architecture document and get approved. So the approval process is making these use cases unmanageable. You don't want that. You don't want security to be a barrier to innovation. So what we proposed is, like, this is, for example, a slide from Anderson Horowitz on the left, where they talk about all of the components you need to have a large language model app. Great. You need all those components. But can we templatize this? Can we come up with a general purpose in a combination of capabilities that are very flexible? And we'll talk about the flexibility in a second, but that are very flexible, but then have a consistent capability be brought up every time. Again, infrastructure as code is a good way to do this. We just created a template that just works. And every time a customer wants to bring it up, it's the same template that is getting deployed. Whether I'm doing a structured data use case or an unstructured data use case, whether I'm doing document generation, whatever I'm doing, it's the exact same consistent infrastructure that is coming up. So the security audits, the architectural audits don't have to be done every time. Now, remember, one important thing also is that most work in generative AI has actually been done on document summarization, the left-hand side of this. And that is applicable to unstructured data. Unstructured data is more commonly available in the enterprise. 80% of your data is probably unstructured. But if you look at data by value instead of by volume, most of your most valuable data, your sales data, your inventory data, some of your supply chain data, all of that is actually sitting as structured data. And in the world of structured data, what generative AI companies typically had fallen down to is NLQ, natural language querying. That actually doesn't leverage all of the power of generative AI. Think of it as NLQ would be the equivalent of exact search in the world of document summarization. You actually want the structured data capabilities, again, to be consistent or comparable to what the unstructured data capabilities are. You want to be able to ask a question like, how can I improve sales? How can I reduce churn? These are not NLQ questions because these questions can't be translated to a SQL query. But these are exactly the kind of questions you want in a generative AI world. To do that, you need the equivalent of a vector database. So basically what the vector database does is you ask a vague question, the vector database understands the intent of it, understands which pieces of document snippets might be relevant for that thing that you're interested in, and then they set appropriate subset over to the LLM for summarization. You need the exact same thing. Our approach is something we call the able information model, where we look at billions of variable combinations very quickly, figure out which charts, which combinations of variables would be relevant to answer a question like, how can I improve sales? How can I reduce churn? And then send the relevant charts over. Again, very consistent with vector database. You should come up with your own abilities, but just think through. You can't just have a tech stack that solves just the structured data problem, or the unstructured data problem. You have to think through your broader use cases and make sure your generalizable stack truly is generalizable. Because if it's not, again, the exceptions will get in the way. You'll spend so much time doing exception handling, creating this standardized, reusable combination of technologies. It's just not going to, you're not going to get the benefit from it. One other important thing of having this as infrastructure as code and thinking through serverless techniques is that these resources are only coming up when they are needed. They're not sitting there and costing you money. That is another reason to do these things as infrastructure as service, especially in a serverless context, so that yes, you're getting consistency, but you're not wasting money bringing up 50 duplicate systems up every time. So the able approach to this is very simple. When you go into Chatable, everything executes in your cloud, and you can immediately just start asking questions. Your questions might be related to analytics, summarization. You could be doing document generation, anything you're doing. The system figures out, oh, you are actually trying to do analytics. It'll come back and say, well, here are some data sets I see. Do you want me to answer the question based on this? You ask a question, it figures out, oh, you're trying to ask a question of a document. Here are the documents we see. Do you want to answer questions based on that? You can use multiple models. You can use multiple tones. The point is you get the complete flexibility of all use cases, and you can create custom use cases extremely easily by changing something called a chat template. But the point here is you have a consistent capability that is flexible. And that allows you to reduce both the risk profile and the approval, simplify the approval process. Because as long as they're using the pre-approved tech stack, they can just get going. They don't have to come back to the security team, to IT for approvals. The third thing you should be looking at is hallucinations. Now, a lot has been said about this, but one of the things I find is a lot of people still don't understand what hallucinations are. I've seen extremely senior people say completely nonsensical things about hallucinations, right? So let's get some of the facts understood first. First thing is hallucinations are real and they are high. If you look at the GPT-4 paper, it was about 75% accuracy in business, which means there was about a 25% hallucination rate. Now, one of the important things that they talk about is the way to solve this, according to the research paper itself, is that you should not use this in use cases where hallucination could be a problem. The second is, hey, you should have humans review the output to find hallucination. Let me point out that in the world of enterprise, neither of these are acceptable. Because if you go to any exec and say, hey, is accuracy in that answer important to you? They'll say yes. Is there a use case where accuracy is not important in the enterprise? Probably no. If I'm writing using ChatGPT to write a Valentine's Day poem for my significant other, maybe there it's okay to not be accurate. But in most enterprise use cases, you're going to very quickly find the lack of accuracy is not an acceptable situation. And this idea that a human being will double check it is just not tenable, because the volume of content that can be generated by generative AI, by definition, is inhuman. A human being can't possibly double check a machine. Just the scale, the orders of scale in productivity are completely different. So these techniques will not work. The other thing that you'll hear from people is, hey, we grounded the data set, we did grounding techniques, and now we don't have any hallucination. Grounding reduces hallucination. It's a very useful technique. Grounding does not eliminate hallucinations. Or you'll hear from people, well, I'm just doing NLQ and the system is generating a SQL query and the SQL query is executing and giving me the answer, so there is no hallucination. No, because the NLQ that got translated into the SQL, hallucination could have happened at that point. So the answer you're getting is not the answer you were expecting, and you don't know because you asked the question, the system gave you an answer. The fact that there was a hallucination in between the question you asked and the answer the system gave you, you may not observe that. So hallucination is a real problem. There are techniques to reduce it, but do not take it as a solved problem. Any expert who comes and tells you it's a solved problem, either they are about to get the Turing Award or they're basically BSing you, and they don't know that they're BSing you. Now, we took a different approach. We said, look, the problem with hallucination is really one of false positives. Business users really don't understand what a false positive means. If a system very confidently gives them an answer, they assume that answer is correct. And thus, what we should do is, yeah, of course, the system is going to, we give the information to the generative AI saying, here are the things we want you to summarize. We, of course, do things like grounding the LLM. For people who are using, hosted LLMs, we do things like masking, k-anonymization, all of that. But when the response comes back, we use a deterministic AI. It is still it's an explainable AI, basically, right? It's something where you can go understand what the AI is doing, but we use a deterministic system to go in and double check the output. Now, understand this. Such a system can tell you whether output was correct. It can go and confirm the facts in the data. What it cannot do is tell you when the output is incorrect. Again, you don't want to make too big of a claim. You only want to make the claim that is scientifically correct. The scientifically correct claim you can make in this circumstance is, I had a system double check the output. In this case, the user asks a question. Everything highlighted in blue has been double checked by Able, and we are saying these things are correct, and we can bring up a chart or a snippet from the document that has never gone through generative AI to show you why the double checking system thinks that the output is correct. What we've done here is anything that is not highlighted in blue, I cannot say that it is wrong. All I can say is my double checking system couldn't confirm it. But to a business user, that is sufficient. What business users want is absolute clarity on what they can rely on. So anything that is highlighted in blue, they can rely on. They can triple check it by just putting their mouse on top of it and seeing the raw data. So what you're creating is a world without false positives. Yes, there will be false negatives. There'll be cases where something is true, but the system will not highlight it as blue. I cannot guarantee that will not happen in this kind of an architecture. But that's a much smaller problem, and users can go in and just say, hey, you know what? Worst case scenario, the parts that are not highlighted in blue, I'm back to the world of normal generative AI, which is I need to double check it. But you have taken that problem from something insurmountable to something which is much more manageable for the human. Another important part of this is that the information that comes up on the right-hand side has to be factual. So if we bring up a chart, there is literally a Python code corresponding to that chart that's sitting around and getting logged in your cloud. If a regulator comes in and says, how did you take this decision? What was the basis of this decision? You need to have a log of what was the chat response, what was the decision taken, what was the actual raw data, how did we get to that decision? And if you don't have that, in anybody who's in a regulated industry, you're going to have issues. And I have a feeling there's a lot of regulations are going to come into the space. So it is better to design your systems with expected regulations in mind, as opposed to, build your system, go execute, and then you find out, oh, shoot, this regulation came in. And one of the most obvious regulations that's going to come is, can you track a decision back to the original data all the way through the steps of the system? If you can't, you're going to have problems. The next thing after this is this idea of monitoring. And one of the things I'm really getting concerned about is a lot of guys are looking at things like, hey, people might put in prompts to hack our system, which is a big concern in the world of consumer-oriented generative AI, because of course you don't want somebody to hack the system and do something illegal by using your generative AI system. In the world of business, though, putting too many constraints around a system is actually a bad idea. Because, for example, let's say somebody has anomalous prompts. So anomalous prompts for us could very well be a case where somebody was trying to hack the system in doing something that it shouldn't. For example, the New York Times journalist who got the AI to fall in love, claimed that she fell in love with him. Well, all the AI was doing was trying to answer trying to give back to the user what the AI thought the user wanted, right? So that is a case that would show up as anomalous, but we also found that some of our more creative prompt re-engineering that our team was doing also shows up as an anomaly. So if you put in these kind of walls and you say, hey, I will not allow you to put in anything anomalous, you're actually going to have a problem. You're going to kill innovation. So don't put a constraint around it, turn that into a monitoring capability, because you're in the enterprise. If you're in the enterprise, you can then find the people who are doing the wrong things and turn off their access. But don't assume that an anomaly is a bad thing. Similarly, you want to monitor every use case, every model across clouds. You want to do it in a consistent way because you want to quickly innovate. You want to try, you want to do A/B testing. You cannot have a situation where you have one monitoring system for Palm and Google, another monitoring system for GPT-4 and Azure. Why not Palm 2 with data in Azure? Why not any other combination? So you have to have a system where you can monitor the information at a very granular level of detail, at the level of the user, at the level of the model, at the level of the use case. Look at positive feedback, negative feedback, get all of that information in a consistent place. And we'll come to this in the very next second, but a lot of this feedback is a major corporate asset. So we'll come to that in the very next slide. So user feedback. I think most people are massively underestimating the importance and value of user feedback. There used to be a common debate in this space, which was, is it about the model or is it about the data? If I have more data, am I better? If I have a better model, am I better? I actually think in the current situation, the better the user feedback, the better the system. In fact, one of the things you'll find is many of these models have gotten big enough that a little bit of few-shot learning actually can give you a really, really good response. Whereas if you go in for a heavyweight reinforcement learning, basically I'm going to train the AI to make it specialized on my data. By the time you've done the exercise, you're not getting that much benefit over just few-shot learning, but you have now locked into one model. Whereas the models are changing so fast, by the time you're done with your whole reinforcement learning project, a better model might have just come in. There are many techniques that are much more flexible. And at this moment, I would focus on flexibility. And that feedback, the user goes in and gives you feedback, that information is your corporate asset. You don't want that information to be sitting in a LLM. You want that sitting in your environment so that you can reuse that information across LLMs. So when you do your design principles, make sure that it is very easy for users to give feedback. In fact, one of the things we do is we make sure that a generative AI project from start to finish takes just a matter of minutes. So a few minutes after starting with a project, we can get something in the hands of many, many business users. So business users can start providing feedback in context. As you saw in this video, they can literally go in and look at the chat response, edit it, and give you a better response back. Why did we do this? Because the easier you make it for the business users to provide you feedback, the more valuable information you're gathering from the system. Today, the state of the art for many of these projects, and many of you have gone through this, is the data scientists go to business and say, hey, could you give me some good examples of good interactions, bad interactions? Let's create a nice little Excel spreadsheet with all these examples, and then we are going to do something with it. Well, the business user is being asked to give feedback out of context. They are trying to imagine what you're asking for. They're trying to give you the best possible information. Sometimes people just outsource this and they say, hey, outsourcing vendor, give me some good examples. Well, the outsourcing vendor doesn't actually understand your business as well as your business users do. So the goal should be to make it extremely easy for the actual users to get their hands on a good enough starting point, not the best starting point, just a good enough one, and start providing feedback in context. And then keeping that feedback secured in your cloud in a way that is portable. So I can, if let's imagine I'm doing a project with GPT-4 and I've gotten some great feedback on it. Tomorrow I decide to move to the next evolution of GPT or the next evolution of PaLM, next evolution of Anthropic, take your pick. I should be able to take all of that reinforcement learning information and move it over to the next model. So design your systems for ease of collection of this information and security of it. Now, people always ask me, what are good use cases? What I really tell people is, we're in the early days of generative AI, just get it in the hands of business users. We have given you some examples by industry, by role, but the reality is your users will find the right use cases for you. As long as you make it extremely easy for them to use, you make it flexible, you make it possible for them to go from structured to unstructured to generation to whatever they want. You'll make it possible for them to combine structured and unstructured. You let them do flexible things, build their own solutions based on the building blocks. You'll be very pleasantly surprised by how many use cases can be done very, very rapidly. So a few weeks back, we were speaking at the AI4 conference, and one of our customers, Sienna, spoke there. And they were talking about how they're iterating on use cases with their business users in a matter of minutes. And the key point was that reduces the fear of failure. If you can do these iterations in a matter of minutes, then failure is not failure. Failure is just something I've learned. Whereas if a project takes 1 month, 2 months, 3 months, and then it fails, that's really a failure. So get shifted to trying new use cases in a matter of minutes. We actually encourage our customers to get things done in about 3 to 5 minutes. After those 5 minutes, get it in the hands of business users, let them provide feedback. And these are some of the things. You can go to Gartner peer reviews and take a look at some of the feedback we have gotten from our customers. This approach of doing the things may sound very strange. What the heck do you mean I should get generative AI projects done in 3 to 5 minutes? What the heck do you mean I can do this without having a lot of data scientists and IT involvement? Well, the proof of the pudding is in the real examples from real customers. And if you're looking at vendors today, don't just go by 1 or 2 codes. Go figure out what the actual use cases are. Have they done it at scale? Have they done it at major companies? Because if they haven't done that, they actually haven't gone through the security issues. They haven't figured out how to deal with the real enterprise constraints that generative AI faces. You guys will have access to the video. There are a lot of links on that, on the PowerPoint that you should be getting from them. Otherwise, just go to able.com and you can get all the information there. And of course, please follow up with Yuda and you can get more follow-up information from him as well. I don't know whether we have the ability to take questions. I'm happy to take some if you have any. It might be safer if somebody in the room just copies it into the chat in case the audio quality is not so good.
I'm really keen on finding out more that has many experience together. What's wrong with that? I think it's really interesting. The idea of going this in minutes is amazing. And you can do it safe with all of the caveats that we know. It should be amazing. I would like to, we're up on the time, but I would like to allow for a question or two if there are any in the room. Any questions? Yes, please, go ahead, feedback.
Can you hear me?
Yes, I can.
All right, perfect. So amazing use case, I think. One of the things that I was thinking about, particularly, this is a product that can actually digitize business knowledge and can potentially be applied to business succession planning. Like if you're really getting old and you want to, like, just thinking about it, many people who get old and they want to like find the next successor, and then they kind of worried about, hey, you know what, is this guy going to be able to pull it? Very common use case. So I think it's a great use case that you've built. And the question is, how do you deal with data silos in an organization, right? Because one of the most common use cases that the HR department is headed by someone, forgive me, Jack. So from Amazon, I mean, he has an Amazon relation, and they might have about AWS, and there might be a different organization, a sub-organization or a business unit, which is a Microsoft shop, right? Totally different data sources. So how do you deal with moving the code over to disparate data silos? That's my question.
No, I love your question. I'm going to answer your second question, then I'm going to come back to your first comment if you don't mind. But to the question, what we do is we say, look, build AI where the data is, and then let the AI communicate. Let me give you a real example we just did. So when an order comes in, this customer was concerned about whether they're going to have inventory stock out because they were having some inventory stock out. So they wanted, when the order to come in, if there is a risk of stock out, give the seller a recommendation saying, don't sell what the customer is asking for, sell them an alternative, right? And they were concerned about being paid. So they wanted to predict right then and there, how likely is it that the customer is going to pay me, so that I don't give scarce inventory to somebody who may not pay me, right? Completely three different systems, right? Finance, inventory, and sales. If we tried to integrate the data, it would have never worked. We just created a predictive model in the world of inventory stock out. We created a predictive model in the world of finance. In both cases, the code was generated where the data was, and we created a generative AI experience in the world of sales. Right? But you're using the AIs, you're letting the AIs talk to each other rather than trying to get the humans to allow the silos to cross, or letting IT to have the silos cross. Now, going back to your comment, by the way, you said something very perceptive I talk about it quite often. Think of AI as a way to create institutional knowledge out of individual knowledge. And that is true of all AI. That is true of predictive models. That is true of generative AI. What you're doing is, when you're taking that user feedback, when you're collecting that information, you are really taking individual knowledge that is not accessible to others and turning that into institutional knowledge that is available to all. And that is why, AI needs us more than we need AI, to be very funny. It's really true. One of the chapters in my book is all about AI needs us more than we need AI. But when we collaborate, when we actually kind of give ourselves superpowers by being empowered by AI and give our knowledge to the AI so that it can scale, wonderful things can happen.
Awesome perspective. Thank you, Arjun. Unfortunately, we're running out of time, but I would love to have more conversations. So I'll give you a minutes and we can chat some more, and then go to our next event for more conversation. With that, thank you. A big applause for my
Thank you so much, everyone.
It's now my pleasure and privilege to introduce somebody who I think most people in this room know very well, Mark Rosenberg. Mark joins us from FIU. He was the former president of FIU, currently heads up an institution and an initiative for cyber policy at FIU. He has been through several roles there. I think he was provost, he was dean, he was, I believe, chancellor of the education system in Florida. So quite a luminary. And welcome as a community leader, and welcome as a friend. Happy to have you here, Mark. Thank you.
Yuda, thank you. I'm happy to be here at Miami-Dade. FIU has a great partnership with Dade, and a lot of our very, very best students are beneficiaries of Dade education. So thank you. It's good to be back. And Yuda, thank you for the invitation. So I'm interested in the interface between technology and institutions, technology and behavior, technology and public policy. And Yuda has asked me to spend some time on issues related to AI, artificial intelligence, and national security. I've worked on national security off and on and in national security for about 4 decades. And there's no doubt that AI presents some formidable challenges to those who daily wake up thinking about national security. And indeed, at FIU, one of our programs in the Jack Gordon Institute is a program that prepares our students for taking jobs with the intelligence community. When they graduate, they already have their security clearances as a consequence of coming through our program, which obviously we're very, very pleased about, because the main focus that we have is on student success. And this new domain, if you will, is one where we've got to be successful. We don't really have a choice. So what I want to talk about this morning very briefly is AI national security. And I was intrigued by the notion of AI needs us, or we need AI. And in many ways, we don't need AI in national security decision making. I can assure you of that. It fundamentally complicates the kinds of challenges that our decision makers have as it relates to national security. And I'm going to try to illustrate why in a moment. So I've got 4 basic themes. One is, let me see, I got to do this too. I'm not a great multitasker, but here we go. The first is that to understand the interface and to understand this topic, we should understand that change is changing. We have to be masters of understanding how change is changing. AI is clearly ushering in a new era for us, and I'm going to talk about that. Second of all, national security doctrine is going to have to change to a new order, a new disorder. National security doctrine essentially has been uniform with variation since the end of World War II. But now we're in a huge change mode. Not too sure where we're going. We've got to figure that out. But at the same time, the international context carries with it both old and new challenges to national security, which complicate the issue of how AI fits even more. And as a consequence, I just want to spend a moment or two on the skill sets that are needed. Let's see. Here we go. So what about change? Basically, change is moving from linear to exponential. And as an educator, I can assure you that I probably can do linear change just about as well as anybody, but I really get impatient with it these days, because in many ways, while we talk a lot about change in higher ed, we don't really practice it as well as we should. Ray Kurzweil put it, I think, best as he was surveying what was likely to happen in this century. He made the point that there will be more change in the first 2 decades of this century than there were in the entire last century. And indeed, I think we're definitely seeing that. He's followed in thinking that's influential for me by Salim Ismail, who talks about moving from linear change to exponential change. And in many ways, many of us are grappling now with how do we deal with exponential change. And that's one of the fundamental challenges, no doubt, we have in higher education. I go back on this to what one of the early change agents of the 20th century said. Now is Vladimir Lenin, in terms of he was thinking through, this process of change, particularly in Russia. And he made the point that, and I'm going to paraphrase it, he made the point that it takes some decades, it takes a whole year to pass. In some decades, it takes a whole year to pass. In another years, a whole decade passes. And clearly, if you think about COVID and all the challenges of that, if you will, tragedy, all the pain that was caused, one thing is for sure, change happened very quickly. I know in the case of our institution, I had a conversation with my chief information officer, Bobby Grillo, about 6 months into COVID. And I said, Bobby, how's it going? He says, Mark, you won't believe this, but we've gotten more done in the last 6 months than I've gotten done in the last 5 years. I said, well, what do you mean? He says, well, we've gone to telehealth, we've gone to teleadvising, we've gone to telecounseling. All of this has happened basically overnight in response to COVID. And in many ways, it's because of that and how we responded that I actually am optimistic about how higher ed is going to deal with the challenge presented by AI. And then obviously, the world's going through paradigmatic changes. I don't have to spend a lot of time on that. You're part of that process. But what I want to do is go back a little bit, just very quickly, to traditional approaches to United States national security. And here I've put kind of the leading proponents, if you will, of the doctrine as it's emerged, national security doctrine. But what I want to point out is that in each of these approaches, whether it's deterrence or containment or rollback or soft power, it's based on the notion that it is the nation state that is central to national security. National security pivots around state-centric approaches and paradigms, whether it's regular warfare or, if you will, border security. Well, obviously, as we know, all of that is changing. Indeed, the Russia-Ukraine war has sent some very, very strong messages and hard-earned lessons about that change. But we see at the same time an interesting phenomenon, in part illustrated by Russia-Ukraine, and that is we see a surge in primordial tensions globally. When I talk about primordial tensions, I'm talking about rooted antipathies and passions coming out of countries related to neighboring countries, related to regions. So it's kind of paradoxical. 21st century, maybe beyond the nation state? No, hardly. We're seeing a return, if you will, to an earlier era, even while the threat scenario is far more complicated and diverse. And in that, clearly, we go from regular warfare to irregular warfare. Now, periodically, we've had that challenge, as you know, for those of you who went through the Vietnam era. But clearly, in this context of conventional to irregular, the tools are a little bit different. We have hackers, we have intelligence operatives who are specialists at massive amounts of information, disinformation, and misinformation. We indeed have a far more complicated scenario of conflict that we have to manage through. And at the same time, these old forces, these old primordial forces are re-emerging layered on top of the new forces. When I got involved in our program at FIU on cybersecurity policy, what I began to realize was that indeed what once was a positive tool of communication, namely the internet and the World Wide Web, has become a tool that has massively increased our vulnerability. Not only vulnerability at the national level or at the state level or at the local level, but at the family and at the individual level. You wake up in the morning and run one wrong keystroke, and you have lost your access to your patrimony, and you may never get it back. And so it scales up from a security viewpoint now from the individual to, if you will, the broader unit. And in that raises a big question for us that those of us who are political scientists and those of us who study policy are very, very concerned about. And that is, can there be a regulatory framework that at once is benign in allowing for individual freedom and liberty, but on the other hand, that enables us to protect ourselves? And one of the big questions that goes to is the issue of, if you will, privacy versus security, which if you look at, if you go to Israel, for instance, and talk with individuals there, they'll tell you, who are involved in cyber issues, they'll tell you that their major concern is security versus privacy. And clearly, we have that major challenge here in this country. Let's see, I went back too far. So, what is it about AI that is so salient, if you will, to the issue of national security? First of all, AI blurs boundaries. What does this mean for national security? Warfare becomes automated. Warfare becomes automated. And then the question is, who really calls the shots? Who identifies the targets? Who identifies the adversary? How much? How little? When? How does that happen in a context where AI becomes dominant in terms of information gathering and perhaps decision making. Second of all, national security in this context is not just an external issue. Now it becomes an internal issue. And that's why the issue of privacy versus security has come on, if you so hard. Cyber security issues are large and small. The person sitting next to you right here in this room could be someone who's going after FPL to shut it down forever, right now, sitting next to you. Or could be getting into your account. So this issue of vulnerability, if you will, becomes ubiquitous. And that's a challenge within the context, even more so, of AI. The technology race becomes paramount. And I'm going to predict right here, Yuda, that you're going to see over the next few years, massive federal funding of initiatives that focus on AI related to our security. It's starting to happen now. It's going to become far more consequential, probably in the context of a new National Defense Education Act. You may recall that we had one in 56, 57 on the heels of Sputnik. Some of you were there, I was. I think we're going to see something like that in the next few, if you will, years. And then finally, what does this mean for you, particularly those of you in the private sector? There's no doubt in my mind, there's going to be a lot more government intervention in your business. There's just no doubt. It has to happen. It will happen. And it's already happening if you look at the whole debate related to Elon Musk and his ability to determine, if you will, the national security of the United States directly and indirectly through his control over satellite communications in Ukraine. And you can now see a sense of urgency starting to emanate that is far different than we've had in the past. And that sense of urgency, my instinct, is going to lead to much more, if you will, federal intrusion. So what's going to happen here? Well, first of all, national security doctrine is going to need massive modification. It's just going to need massive modification. Second of all, our government is going to reorganize itself for a new technology race, and is going to have to prepare for new forms of conflict, because our national security structure is massively poorly positioned for what's coming at us now. Thirdly, new regulatory frameworks are going to be developed. And, you know, there are debates going on now. We even had one in our advisory board a couple of months ago that basically was characterized by the larger companies having one view and the medium and the smaller company types having quite another view about how this regulatory framework should evolve. And then, of course, as I said, more intrusion. So what competencies does that leave us with? I identified 8. But I just want to talk really about 5 of them. First, on flexibility. I think we're going to have to become a lot more flexible in terms of how we make decisions, in terms of how we get information, in terms of who we listen to. And the way I look at it is that increasingly we need to gear ourselves to expect the unexpected. Anybody who is surprised today by the unexpected probably needs to think through the range of scenarios that could be upon us in any circumstance. And in that context, ambiguity, in my mind, is the norm. And for people who move to South Florida, if I have a chance to meet with them before they get here, I say, listen, you gotta understand something. If you're somebody who needs routine, do not come to South Florida. The best you can do is a rhythm. And it's a rhythm of disruption, a rhythm of uncertainty, a rhythm of ambiguity. And you need to be good in ambiguity. If you're good in ambiguity, you're going to love it down here. And in many ways, that's where overall this whole arena is going. So that's 1. 2, emotional intelligence. in all of the work that I've been privileged to be engaged in working with academic departments and boards of trustees and other universities, department chairs, leaders of all kinds, students. The one point that I continue to come back to is the importance of emotional intelligence. And that, for me, that issue of emotional intelligence now more than ever means find a way to walk a mile in somebody else's shoes before you make a judgment, before you make a decision. And if you can do that, I think we're going to be a lot better off as in our civil society. Right now, emotional intelligence is at times in short supply. And one of the things that you learn if you work in the policy arena, particularly if you're trained as an academic, which I am, the training really doesn't serve us very well, in part because we're trained to recognize that, to believe that that reason drives emotion. That reason drives emotion. When in fact, if you look at the policy world, even with all the data, even with all the analysis, even with all the thoughtfulness that's there, it's emotion that drives reason. And the sooner we can figure that part of it out, the more effective we are going to be in terms of restructuring what we need to restructure to preserve information security and reduce citizen and community vulnerability. The third issue, strategic thinking. For me, the issue of strategic thinking boils down to clarity. It's very difficult to get clarity these days about things that you're, the ecosystem that you're working in, the boundaries of that ecosystem, the nature of humanity and how decisions get made. But if there's a way to get clarity, that will help you to drive intentionality. In terms of clarity will drive intentionality, what you can and should do. And I think there's no bigger issue. I mean, think of the conversation we've just had on ChatGPT. And it's kind of a dynamic of, hey, here's our clarity. This will help your intentionality, but remember that there are limits to the clarity we can have that ChatGPT gives us. So clarity drives intentionality. We need to work harder on that. On the digital capacity, I think most of you would agree that we're just at the beginning of where capacity challenges and opportunities are going between the Internet of Things and between quantum computing and CRISPR. We are just at the front edge of that paradigm change, and we've got to do a lot better to understand what that's about. In our case at the university, one of the things that we've done to help us is we've been very aggressive in setting up metrics of measurement and down to the unit level. And so a lot of the opportunities that we've had to move up in the rankings have been driven by our focus on our willingness to set metrics, to identify numbers, and to hold every unit to those. That's helped us a lot. And my instinct is, as we go through more digitalization, there's going to be more measurement. Units will be measured globally, whether you like it or not, you're going to be measured. It's going to be transparent. It's going to be out there. We got to get our organizations ready for that. And then finally, in terms of strength and resilience, I come back to the issue of optimism. It's important to have optimism about the present and the future. The research that I've done, I've been very interested in negative frames and framing in general. And what I've seen is that negative frames tend to galvanize thinking in directions that make it harder to have the flexibility that you need with the challenges ahead of us. So in summary, what my message is, change is changing. Do we really understand that? National security doctrine is going to change necessarily. The international context is going to become more ambiguous and contradictory, and new skill sets are required. And I'm happy to answer any questions or further confuse you if that's your choice.
We don't have insight and enforcement. So, question please.
Hi, thank you so much for your presentation. And I have a question regarding when talking about the competency needed for leadership. So we mentioned the strategic thinking part, and there are several metrics, like you mentioned, need to be set up. So from your point of view, what will be a good way for people normally like set up those metrics? Is it through like a panel discussion, or is like inquiries from like the mass? Or what will be like a good recommendation for that part? Thank you.
I think it's a good question. How do you set up metrics? How do you think it through? My instinct is you start at the broader context level. What is the context in which you're trying to understand those metrics? Who are the leaders? What are the best practices? How do they measure? And how is that measurement relevant to your context? That's one. Two is that there needs to be a discussion with a group of like-minded people. By the way, every unit has change agents in it. All right, you want to know who the change agents are and what they're up to and what they're thinking. Every unit is going to have leaders. Every unit is going to have, for lack of a better word, laggards. They're not going to be change agents. They might be willing to go along, but they're just not thinking about change in the same way that you need to. So identifying those leaders and forming a coalition with them and trying to get them to identify relevant, viable metrics, I think is important. And the reason I say be positive is that I try not to listen too long and too hard to negative people. And they're around us, we know it. I mean, that goes with the turf, and academics are trained skeptics by definition. Some have already become cynics, but by definition, skeptics. And so, but find those who have a broader vision for the future and want to, and have the courage to get there. And then finally, if you're going to fail fast. There's no fault in failure. The fault is in not figuring out what you could have done better and getting on with that. So I've come around a lot to the issue of metrics in part because at least in a public setting, and many of you represent corporations that are public, accountability increasingly is going to those metrics, those measurements that are going to be global. They're out there. They're going to be, if they're not out there now, they will be out there, and that people will make choices about who they collaborate with, who they cooperate with based upon the reliability of those metrics.
So for me, my education background, so I got my PhD in physical chemistry, and I totally understand that there are people that are super critical, and a lot of times when you propose something, and the most people or most hungry about that they're gonna work, and they always gonna say that.
Yeah.
So for your perspective, what kind of advice would you give to folks that they try to always approach stuff from the really critical, even cynical ways? I feel like it's really hard to convince people,
right.
Especially when their mindset still.
Okay, so when as Yuda said, I've been through practically everything in a university context. When I became a dean, one of the older deans came up to me and said, "Mark, you're going to become a dean. Do you know what you're getting into?" And I said, "Well, I'm not sure, but tell me what do I need to know?" He said, "Mark, on any given issue, 30% of the faculty will tell you privately what to do. Another 30% will be opposed to what you want to do, not because it's a good or a bad idea, just because they can oppose you. And the remaining 40% genuinely won't know what to do on that issue. But you can rest assured of one thing, on any public discussion of that issue, the 30% who privately told you what to do will not say so publicly." So what that told me was that, you got to have courage if you're going to be in a leadership position. And I think the best you can do in that is to be fair and consistent. But Lincoln said, if you get to a rock in the field, plow around it. And lots of times, the situations that I've seen are situations of asking a colleague, do you want to be right or do you want to be effective? A lot of colleagues would just want to be right. They don't care about being effective. Right? I don't care whether it's public sector or private sector, profit making or nonprofit, they just want to be right. But I think in leadership positions, that's why the clarity and intentionality is so important. My instinct is you want to be effective. That doesn't mean you're going to be immoral and unethical. What it means is you've thought through, it may not be the shortest distance between 2 points. It may be a zigzag because you've studied your ecosystem and you understand where the rocks are in the field.
Yeah, I have a question right here.
All right, Mark, thank you for your presentation. It's very good.
Well,
But many of the speakers that I've heard on this topic have indicated that large corporations and technology are the new power brokers.
Yeah.
Versus emerging economies, China, et cetera, that they will play the largest role in the new world order.
Right.
I do agree that, well, not that it matters, but I do agree that legislation is required. What is the remedy for the political obstinance and sort of clownery that limits legislation to manage technology companies?
okay, so what is the,
Yeah, let me be more specific.
Yeah.
I think a lot of folks would say that legislation is necessary. However, the focus can't be placed or the resources aren't there to make that legislation happen. How do we solve that problem?
well, I think it's a really good question, and I don't necessarily have an answer for that. And clearly, there needs to be a guiding consensus that evolves. And right now, I don't think we even have close to a guiding consensus. And really what this gets at is there's a whole thesis, and you can look at it in I think the most recent articulation of it is in Foreign Affairs magazine, which was an excellent piece called The Power Paradox, which deals with AI and talks about how difficult it will be that AI is essentially largely being driven and owned by the larger companies in the world, and that the US government and other governments are going to have to share power in terms of determining what happens with AI. My instinct is that you're going to see some, how shall we say, hardcore veering in terms of legislation coming out of the US Congress that will temper the worst instincts of corporate autonomy and go it aloneness. And I think that there will be a middle road that will be found, but I don't know when and where. I'm not too sure if that answers the question, but yeah, I think it's going to be a process. It's not going to be an event. Thank you.
Thank you. Thank you very much. So with that, having the right level perspective, we're going to move into another session where we're going to talk a little bit more about the constraints that are out there, the compliance issues, and how to approach them in this changing world. We have two great speakers, Regine Bonneau, who's the founder of RB Advisors. She is a specialist in cybersecurity compliance and risk management. And she has been working with clients in commercial and government sectors, and also in industries, including defense, healthcare, fintech. And so a broad background. So I look forward to your views on the matter. And together with Regine, we have Adonis Sardinas with Fortinet. Fortinet is one of the top providers of cyber technology defense software. Adonis has served in several companies as a security manager and officer. And he's also got a collection of 4-letter security certifications. And so he's a specialist in the matter. But welcome both, and please tell us.
Do we need the microphone? Can you all hear us from back there?
Can you hear me?
For both or? Yeah. Oh,
Do you have another mic? Yeah.
you can have that. One second.
Thank you. Here's a. Oh, awesome.
So I'll let Regine grab this one. So thank you all for coming out today.
thank you guys for coming, and, as you know, we always talk about, when new technology comes around, how do you say?
Exactly.
See? Right? So anything that we've been speaking about, that we're hearing about, is, we've seen that is nothing new, right? But it's always something that's evolutionary. So-
So a little bit about me, I've been
Oh, okay.
working in the field for over 20 years, so I figured we set credentials for our where we come from, how do we know where our expertise, so you all inform your questions accordingly to each of us. I'm serving on the board of advisors for both Nova University and MDC on the cyber side. And I'm also a professor at the Jack Gordon Institute on cyber threat intelligence for anyone who wants to learn a little bit about the unconventional warfare that exists. Feel free to join my class every Tuesday from 6 to 7.
I'm joining the class. But also just part of my thing that I do aside from just being in the risk management and cybersecurity. The goal was to look how do we start working with you with the technical side and also the management, right? So and this is why we have today. Understanding why all of these technologies, new or not, and how it's affecting us. So part of what we're presenting, right? What we're saying is you guys requested help, right? We hear that there's a shortage in cybersecurity professional, InfoSec, CyberSec. We're working, we're overworked, we need help, so we requested it, that's why. The industry delivered, and now we're looking at. Now what do we do?
Right, so everybody captured that, right? Does anyone remember the references? No one, everybody's too young to remember that show and robot. Anyways, that's.
I guess the young ones.
Yes, right, and that's Helga from AR. So right, everyone demanded, hey, we want things to be faster, we're demanded to do more with less, at least in my realm of work, and as I can imagine everyone else's. We're rapidly advancing in the technology of AI and what we can do with it. So, okay, well, it's here, now what, right? We ask for it now, how do we frame it and use it in our day-to-day, at least to, as Mark had mentioned earlier, right? We're coming into unconventional warfare as an example of leveraging AI for that. And also in the cyber defense area where I sort of live, how do we leverage that to be faster than the attacker, right? Because you are all here today, you woke up, you got dressed, you're here to learn more about it, while the attackers are doing a phenomenal job of communicating with one another and exchanging tools and already leveraging far more advanced than we are, generative AI.
Some of the things that we'll discuss, right? Have you guys, do you recognize any of these primitive AIs already? So, but those were prior to, right? That was the introduction of somewhat aside from a smartphone and one other thing that we had AI, right? So, but those were just.
No, it's
so a lot of those brings us learning as we go, right? What we tell them people do this learn. So now since now moving to the next generation and squad here. We're afraid of that next generation because that's what we listen to throughout the whole way. And what we're being is that it doesn't need all permission to get it, but it's needed. You ask, I'm going to get it. If I can't get it from that perimeter, I'll just go put it somewhere else and put it to you. And this is where we are now, trying to figure that out. So where are some of the organizations that I deal with, and then guys still will do it, right? Where are you guys within your organization? What we're seeing is some of them on the subsurface approach. It depends on the industry that you're in. You start looking into that aspect, do I go in, do I not go in, but we also realize we're somewhat into that stance of it. And some other ones are pragmatic, right? So what are some of the controls around it? That's where you saw that's just mention about regulation that we hear about. Everything comes with regulation. We just dealt with GDPR and now it's back again, right? Because we're dealing with data, what do you call it? It's black hole, right? And then progressive approach. Which one of us here would really go and progress about it, right? But there's steps that you put in the organization at different sizes and phases that they're doing.
And here, let's do a quick poll. So how many of you are working? How many of you are working in organizations that are taking a conservative approach towards leveraging AI? Raise your hand really high so we know who you are. Okay, don't be ashamed, it's okay. How many of you work in organizations where they're problematic processes? Okay, and last but not least, who is embracing this with open arms? Who's working in an organization where, well, I know Trump is. What's funny here is that at least in my organization where I work at, we're programmatic. We do have a very strict guideline on what our staff sort of, and we have, in our case, we're gonna have a very strict guideline on thou shall not use ChatGPT. The reason for this is potentially customer data in our case, right? So I'm noticing maybe when Virginia is talking about most organizations, because we are leveraging that in the organization, the back end for a lot of the products that are out there to help in the defense of these new age attackers leveraging AI. I don't know if there's specific about.
In my world, it's all three, but it's all depends on who, right? But a lot of it is obviously depends on the extensive or the maturity of their street staff, of their internal infrastructure as well. Is looking at what are the controls that involve it, and I'll leverage what I have with it, and how is that going? So I'm still stuck in the middle at times, and then you see in a healthcare organization where you're like, no, right? And this all depends as well, right? So
You said a good statement there, the maturity. So for those that raise their hand under a certain approach, what is the first assertive and programmatic? What is the maturity of your cyber organization? Because Charles Santa, I know his security maturity is at. No pun intended, but I love you. But the rest of you that are programmatic and conservative, how mature in a scale of 1 to 10 do you feel you're on the higher side or the lower side? So on the higher side, those that raise it, right? Okay. Anyone else? From higher security maturity, right? A deeper understanding. Now, those that were progressive, this fine gentleman up here, what is your cybersecurity? How do you feel your cybersecurity maturity is in understanding of?
Because we're running startup, so of course we're going to use it as leverage as a tool to stand up the conversation.
No, but your cybersecurity maturity with which is your knowledge and understanding of cyber.
Oh, we're just working with process.
Okay.
That's how it's.
All right, so to summarize, right, where you see the progressive is, hey, we're just going forward. We're bringing it in. Security comes after the fact, right? Whereas the other folks that raise their hands, we live and breathe cybersecurity. We understand the dangers or the potential of danger of this. Therefore, that's why you'll say conservative mode or programmatic.
So, we figured out all of these now start combining with your governance with compliance. You know, those are best friends, and they can have their risk as well. When we're looking at using it, so some of the gentlemen that lead their hand, when you're looking at, well, we're a little pragmatic, but now we're working also with your governance and compliance department to help that staff, right? But to give that space, you should already in that alignment. And why is that, right? Everything that we have, why are we here today? Because we forgot to see that it works, right? The governance, guys spoke about policies, procedures, what are those things people start adopting, even though that's some of our employees already have them, right? So how do we start now, start looking things in place to get that from happening? Then you're looking at more standards, we've been hearing about all these new regulations that are coming out, regulations that we've already had. And what these regulations are is who protect the data. So is it too much or more? It's probably not. It's all about now, how do I start applying those regulations, those data privacy regulations to what we're looking at in AI. And why are we so scared about it? Because the information can be coming from anywhere. Our information enterprise are looking for it, right? So when you're looking at testing and documentation, that's where we start looking and bridging with employees and customers, right? So what we're seeing on my group a little bit is that No one knows, right? If I don't know, I'm going to do what I need to do. If I'm not part of the conversation, then I don't feel like I'm wrong. And then you're like, well, maybe my job is going to be taken apart, right? How do we start having that communication while we're talking about our process of governance? And it's inclusive, right? We need part of it, adding those into it, make them part of the process versus not. And if you start adapting to it, then it's easier process, just like cybersecurity. If you're putting some new process in place, guess who goes for it? Your employees, MFA, I think was still fighting with that as well, I think some of my people with that, right?
Many folks in the room do not use MFA. Maybe the question is, who doesn't know what MFA is?
No.
It's okay. There isn't one. Wow, all time. How many of you use MFA for your personal activities? Okay, so those that didn't raise their hand, it was a few hands out, don't use MFA for personal banking? Or don't use it for their Facebook account or their Instagram? Those that have their hands down, how many times did your Instagram account been hacked? Or gaming account? We have a friend that their gaming account was hacked for lack of MFA. So there is no platform too small or insignificant that you should not be concerned about multi-factor authentication, as it will probably start seeing something similar for those boundaries in generative AI's form, right? Where now we have access down packs. Hopefully we get something in the near future on similar to that for generative AI.
Awesome, next one. So some of the privacies, I think I started mentioning some of those things, right? So we're looking at Canada, right? Canada as always part of the but it's a little bit more forward as it's coming into data privacy, right? And we're starting to understand, especially in the healthcare format of it. So you have the Data Act and AI Act that's coming along as well. And of course, they give you our favorite counterparts, right? The more progressive ones, GDPR is adding a portion of that into it, and now it's separate, right? Why? Because your citizens' information, as we know, is important. Why should that matter to us in the US? Have they been reading their voice, right? Now we're global, we know we're global, it's a economy. We don't know where we are, we don't know who our clients are, who our patients are, who even some of our employees are, right? In a sense, right? And, right, so we still have to abide by some of these processes because those are much dependent. I always say, right, whatever strengthens is whatever power, and then we can go back from there because eventually it's figuring them down. I know California just introduced another one, right, into their privacy act as well for their own students, right? So why? We understand what they're making of. So this already has this management framework. So we're not really reinventing any wheels, right? Now we're looking to see how we start looking at those things that we're already doing and adapting it to this new technology I call it, right?
Yeah, so shameless plug here.
Yes.
With Regine, feel free to leverage consultants that are professionals in the field for those that are progressively adapting AI, so you have a better understanding of, hey, I want to do all this work, but I also want to safeguard my client's data, right? Because that's important to me. That's what's going to keep me in business. It would not be wise that you get a fine for millions of dollars for the potential leak of a customer data, or then your AI solution was involved in another AI solution. As we'll see forward, we'll see a little forward about AI versus AI, right? Because it's coming. We're just, how do we put these bumpers up, and how do we safeguard the most critical asset to us, which is anyone? What's the most critical asset to the digital realm? Data. Right? It's crazy that data hasn't become, like I think in our world, like a record, it's about 250 a record, that's crazy.
And that's changing, right? But then when we start looking at all these other things that's coming into play, so we have to start stopping and then start thinking. Yes, we can be progressive, yes, we're combating, even as conservative, big steps that we start taking. But now he's looking, we're not asking to go back and redo what you've done. Is now take a step, reassess what you have already, and now how do we properly move forward or continue monitoring this? Some of the ethical stuff that we're looking at, right? I mentioned a little bit, we see some companies policy. But policies are there, but how do we start enforcing those policies, right? There's other factors that we can use, and also getting the aspect of the aspect of the executive, right? And we know where all of this starts, right? We don't own the data, I know for sure I don't own the data, but however, who is going to direct it, right? We mentioned, if you do data impact assessments, all of your assessments now needs to get the tool as a whole. Am I going to use an AI tool to do my assessment if I'm looking to do AI? Not really, right? So it's all of those counterintuitive, and I'm saying that because I have an example on that. So let's make a stop on this, right? And then be accountable, transparent, that is across the board. And some of those things that we're looking at, and also rigorous access control, you think that not change. Is this now we have to put a closer look to it and look more, because some of us will call it virtual assistant or digital worker. And the digital worker now have access 24/7. How do we monitor that and look into that package moving forward? And as we always do, continue to the new worker system now. For some of the fun part, I'm like not the fun part, but some of the fun part of what we're talking about is happening, right? So what are we seeing in generative AI and how is that sort of combating against it? That's up to us. So I'll go back to
Thank you.
honest.
So this is my favorite, so I'm gonna take the clicker, okay, what's in my hands. So as I mentioned before, my background is in cybersecurity. I used to be a pen tester. I got paid to go hack people. It's kind of crazy that you can do that as a job. And what I tell folks all the time is, do you want the good guy to tell you what's wrong with you, or do you want the bad guy to tell you what's wrong with you? What we're noticing in the field, in a research lab at WordNet, and also in conversation with other leaders in cybersecurity out in the industry is, hey, are we prepared for this scenario? Right, as Mark said, unconventional warfare. And who is making those decisions? Is it a person, a human with emotion, or a robot? Who do you want to make that decision? I mean, we're almost letting the cars make that decision for us, like, hey, you should turn over here, so this is saying, right? But what when Skynet opens up and we're looking at the eyes of a robot, we're ready to pull the trigger? So these are some examples of attacks on AI itself. I'll let you all, take it in. So sponge attacks, in-reference attacks, hearing with AI, so oversharing and leaking confidential information, which is a concern from a privacy perspective. We ask the AI units, hence why our organization, as an example, is conservative on the adoption of AI, because what happens? Someone within my organization leaks a configuration file for a firewall for the DoD, Department of Defense, and someone at the other end gets goes and finds this device. Hey, can you please give me an example configuration of DoD? And it spits out all their encryption keys, passwords, and so on. Right? So this is the worst case scenario, but it's been seen. I think there's a few use cases where you can ask ChatGPT, hey, write me a story on the malware that goes alongside to this particular device, right? And it was better enough, so there's no restriction to it, right? Nobody there to control it. So we're gonna go over we're gonna review the document in 2 parts. We're gonna review it from the defense perspective, or we're gonna review it in the defense. Who does not know this reference up here? Okay, I mean, anyone not know this? Raise your hand. Okay, just to understand who's not in the field, right? So cybersecurity coaching by Lockheed Martin. It is a Bible that cybersecurity professionals run through, which gives us an understanding where in the phase an attacker is, and also in defense. Real quick, where do you think you want to catch an attacker? So based on this chart, where would we want to catch him first? Recon, when they're learning about us, right? And generative AI, guess what? It's constantly doing reconnaissance. How do we know that it's a human or machine? So when we go into reconnaissance, right?
And I'll walk into the story or the flow is AI doing reconnaissance on a particular target, an IP address in most cases or a user, right? It can now self-weaponize. It has access to all these GitHub repositories, all this data. So whereas an attacker like myself, back when I was responsible for pen testing, having to Google and identify a region to my tool set that I already knew worked with. This guy is doing it in seconds. I've actually asked it to write up a malware, not a malware, not specific on malware, but I asked it to make some tweaks to a tool that I used to use, and I was just so immensely impressed and scared how quick it responded back to me with a weaponized tool that I could use, right? Where I need to component. Then we go to delivery. We're now facing AI generating the phishing for us. It's going through this process automatically. All I have to give it is a target, and that target is you or your organization. Right? And then I'll do all to this. At some point, as Dr. Rosenberg mentioned, we're not pulling the trigger. The computer is. We just gave it an endpoint by using. So what are we doing on the defense side? And this is what I had mentioned earlier today. So I've seen it firsthand where the government is obviously on the conservative side because it's scared. What if it goes wrong? What if what they develop goes out there and starts pulling the trigger on something? From the standpoint of the defense, with reconnaissance, we do have tools that do that. We're now adding generative AI into it so that it finds repositories in the dark web of users sharing this information. So what I used to do manually, go on the Tor number, go to a Tor website, I'm going to website, talk to that center, it's going to do it for us. At some point, right? So right now we don't have it where it automatically goes to start having a full-on conversation with a hacker or with Telegram or WhatsApp. Well, we can have it log into a Tor network, browse some of the forms that we would go on and hack as soon as possible to do reconnaissance and identify what's someone's trying to research our defense, right? So SIM stores, we're going to see an AI version of that real soon. Detecting weaponization of it, the most part weaponization is not getting email. Most of our email security appliances will detect based on, oh, this is on my list. With generative AI on the defense side, it's going to go further and test that link constantly. Through search, the dark web, where a human would have to go ahead and put the definition. In the delivery phase, so weaponization, they found these malwares that's in GitHub or the dark web. Delivery, that's through email, and already made it to your inbox. Exploitation, this is where you're seeing solutions such as next generation firewalls, EDR, XDR. So EDR is actually the next phase in behavior-based endpoint protection. You have endpoint protection, so EPP. So if you ever hear these buzzwords, EPP is signature based. It's old school. We're starting to run that out. It is faster than behavior based, and so the AI example of endpoint protection is EDR, XDR, and MDR. And then as we go on down the line, where you see exploitation, installation, command and control, and actions, this is where a new and upcoming products, NDR, network detection and response, is coming into play. Where now we're seeing packets just go across the network. Hey, we made it to the endpoint. But this endpoint starts talking, what do you have that's monitoring that traffic and understanding if it's doing something malicious within your network? For example, doing a brute force attack to explore a little neighbor who has no idea what's going on. And so it's monitoring the network and making decisions. So it's behavior based. Hey, this computer doesn't normally talk to this computer. What are you doing? Hey, I'm going to go ahead and reach out to the web and how often do I see this happen? So that's on the defense side. So what I want to put in summary here is that the attacks are faster. The sophistication of the attacks are faster today versus our defenses. Right? And the only thing that's going to change this, in my opinion, is folks that are progressively looking at AI, generative AI, implementing that to share information. Also within the community, as I mentioned earlier, the bad guy is communicating 20 times faster than us. Yuda, keep me honest on my time, how much time I got left? Perfect. The bad guy is communicating at a rapid speed. Okay, so. We have to communicate faster so we can enhance our defenses. So we can do traffic detection within network security, right? Faster phishing detection because they're getting very good. Who's got, can someone give me an example of a good phishing? Like you looked at this email, you were like, man, that was good. No? Anyone? Every day. Anyone that had their hand on, oh, yes, cyber, yes. Like Gamma was good. Okay. So they're even using, right? They're using, you got a job offer for yeah. And the gentleman over here.
I work for Microsoft and they send internal phishing mails naturally, very hard to spot. And if you call for them, sends up a
Right, so I pointed this out because it's not just a crappy look at like Facebook or Amazon anymore or a $500 gift card. They understand this shit doesn't work, right? Certainly.
we got corporate credit cards. And we got a phishing email that asked us, to get in and do something. I don't know, I can't remember what it was, but it was scary the amount of information the phishing people had about the corporate credit card, who it was, who we were. And a lot of people clicked on the link and they shut it down quickly, but.
So I'm glad you mentioned the point about data, right? Amazing how much data they have. Imagine how much data they're going to have if we don't get ahead of their ballgame with how we protect our data, right? A lot of these companies are spinning up, collecting all this information. How easy is it for the attacker to pull it up, right? So we are seeing AI in the financial industry as well for online frauds. And as I mentioned, behavioral analytics has been for a while, so we just going to further develop, help further develop, and I will pass the mic back to Regine. So she understands the reference. She gave me this, and I was like, I don't understand.
Even out of time, right? But this one, I was doing this and looking into where we are today and where we've been as well, right? We're all here together, but at some point that we all escape. When we started last, we delivered, and now we all feel like we're still in our own little bubble. Right? We've escaped, right? We're getting what we need, but we're still operating now, afraid to actually be free to use it. So hence why we were saying, what are we doing? How are we getting it done and where are we going? So could put more movie stuff in there, but this one fits perfectly. Now what is what we need to do? So one of my other favorite movies.
It didn't work.
If you see, I know what, the first time I saw it, I was like, oh, that was it for me, right? So getting you on that, right? So my logic is undeniable. I use that all the time, and then where are we heading? How do we get from there and not get too far off that we're falling off? So thank you so much.
Thank you so
And
much.
if you have any other questions, we'll be around.
Yeah, we're around. Thanks so much for that.
So I really
What's
wanna,
that?
I want to thank you both for bringing it down to the reality. The little tilt changes though, really breaks it down. Here's what's happening beyond the concept. This is happening day to day. And people like two of you are out there watching and helping us to stop it. So thank you both for the presentation. And with this, we'll take half an hour for lunch. They're here for more questions. And so is David from Microsoft. I saw him, he's right there. Yes, and so is Dr. Rosenberg. Enjoy lunch and we'll be back in 30 minutes. Thank you. Do you meet David?
No, he's right.
CMO. Allison is Cybersecurity CMO and she's been there with them for the last 7 or so years and has been part of that success over there. So again, thank you both for being with us and please take it over.
Awesome. Thanks so much. Hi, everyone. It's great to speak with you today. I'm super excited to be joined by Patrick, our co-founder and chief product officer. He's really the brain in the jar here over at Cybersecurity. We've been building. Can you hear me?
Yes.
Okay, cool. We've been building for the last 7 years or so, a platform to help organizations manage cyber risk. And we've used AI in various different applications across the board for the last 7 years. And Patrick really is the one, innovating around this. And so I'm excited to speak with him and have this discussion today. So with that, Patrick, do you want to share your screen?
Yep, I'm working on that. Just give me a second here.
Cool. And thanks to everybody for putting on this event. This is really awesome. I'm actually Miami based, so I'm going to head over there after we have this session here.
Can everybody see my screen?
Yes.
Great.
Awesome. Great. So I think we're all aware that inside and outside the cyber world, AI is all the rage right now. It seems like every startup, every company is claiming to be an AI company. And when I talk to chief information security officer friends of mine, one point comes up time and time again, and that is that AI for the sake of AI does not help us much unless it's grounded in practical use cases. Patrick has been on the forefront of this for many years, looking at how AI can help solve classical problems in cyber risk management. And today we're going to dive into 4 practical use cases that are not theoretical, but these are actually ways that our customers today, that enterprises that we talk to on the cutting edge of cyber risk management are using AI, whether it be natural language processing or Gen AI to help solve problems at their companies. So I want to go to the next slide. So with that, I'll pass it to Patrick, and he'll talk a little bit about the state of AI and cyber from a risk management perspective, and then some of the opportunities for advancement before we get into the agenda here.
Yeah, so again, thanks everyone for having me. Really excited to discuss this. As Allison has indicated, our approach generally has been to limit AI to the applications where it really is appropriate. My background goes back 20 plus years in AI, and really back then it was, we just called it problem solving and, analysis on large databases. So, when I joined the firm here, my background was kind of a natural fit. I hadn't really looked at the problem in cyber, and there were some classical problems that are still, out there in cyber that were, candidates for early, innovation on our part. The first one was we work with a lot of security frameworks. So we work with, the cybersecurity framework. We work with NIST 853. We work with HIPAA. We work with COVID. The list goes on and on. There's hundreds, if not thousands, when you go international on the frameworks. One of the major problems that security professionals have is working inside a certain set that might be core or native to their company, and then having to report out on another framework that a regulator might be asking them for, or a supplier or a vendor might be asking them for. The state of the industry when I kind of came in was there were some mapping concerns staffed by human intelligence that would relate, controls across multiple frameworks. This to me seemed to be a great candidate for NLP. You could train a large model and get tighter mappings. In order to do that, we kind of had to break controls, but I'll talk a little bit about that later. The other areas that we've been pulled into that are fascinating are areas that some companies have done a very capable job of building AI with large data sets around threat hunting and behavioral analytics. We got pulled into it because there's a huge opportunity in vulnerability language to be a little more predictive and to be a little more prescriptive on the mapping side, and to answer a whole host of questions instead of just one question. And also to answer those questions in a context that the business can understand. There's a lot of applications out there at the moment that sort of have narrow focus on a set of technical questions. There's some brilliant work that's been done in there, but often the outputs are not consumable by the business side. So we're very interested in maybe a world model that rationalizes risk on large data sets and telemetry. So that's the broad approach, and the 4 use cases we have will touch on all of those.
Cool. And on the next slide, we'll jump into the agenda that covers those 4 use cases, or we're going to get right into use case number 1, even better. So First use case we're going to cover is leveraging NLP for regulatory compliance. So organizations are struggling to effectively comply with frameworks and standards. Those are sets of controls or requirements. And a lot of the times these frameworks say the same thing, they just say them in different ways. So there's an immense amount of wasted time and resource put into compliance due to requirement redundancy. And these requirements are coming from customers, the regulators, business leadership. It's hitting the security program and the GRC program from a variety of angles. As Patrick mentioned, there's limited crosswalk data available between security frameworks. And a crosswalk, for those who may not know, is essentially a mapping or translation table between different frameworks, and that helps us get insight into how those requirements relate to one another. So our solution is using NLP to identify and put to work the semantic similarities between those security frameworks versus the conventional approach, which is mapping one framework directly to another. We break controls to their component parts and map those component parts to each other. So what exactly does this look like? Patrick, do you want to speak a little bit more to that?
Sure. Yeah. And I'll just switch to this slide because this is what it looks like practically when you get it done, right? It's the ability to take a source framework here, in this case, NIST 853 special publication. There's two revs out now, Rev 4 and Rev 5, and map it to another framework entirely. And in this case, it's the Center for Internet Security's sys controls and subcontrols version 8, which has 18 controls and then approximately 10 subcontrols per control. So why do you do this? Well, historically, I'll just ground it a little bit in the historical situation. A lot of the large consultancies will charge a good deal of money to do these mappings. So it's been a business for a long time. And then there was a concern called the UCF out of New Orleans. They moved to California. It was staffed by lawyers who would just go through vast amounts of regulatory language and map them to each other. The problem is that the mappings, which we call industry standard, don't take into account the atomic parts of controls. So there wasn't a way to sort of break control frameworks into their component parts. So you couldn't get type mappings. You could get sort of neighborhood results, but you couldn't go from one action inside one control framework into one or more actions inside another. And that's what, we trained up a model to do that, a dense neural net, with some different sub parts to it. One was coarse, sort of to go across maybe slightly different frameworks, and one was fine to relate frameworks that have high semantic similarity. So it's broken into a few components, that model, but it's very useful when we're doing mappings. You can look at it at 90% confidence, you can look at it at 95, you can look at it at 80, and it's fascinating, the results. We're currently building out the model as well inside of IBM, who's a partner of ours. The actual data training set, which I worked with, was scraped from the internet. So we pulled all the security language we could find on the planet, and we fed it into the model. That project is not complete because new regulations come out all the time. We missed some standards. There are standards in the Middle East that are very informative. There are standards worldwide as well. So some translation is required to update the model. But that's the basic approach. And this saves professionals vast amounts of time. So it's a really practical application of NLP. We're really proud of it. And it's also kind of core to sort of the rest of the models that we'd like to build, because in any generative model, you're going to have, this is sort of the inner workings of it. And then you're sort of turning to what can it produce aside from confidences or statistics, and what can it produce in terms of natural human language itself. So that's our first use case.
So jumping into the second one, really talking about bridging the security language gap. And Patrick mentioned this earlier, but just a little anecdote. We've seen Big Four consulting firms charge upwards of $800,000 to a large enterprise to get some of these mapping projects done with months of work. So using this can be immensely helpful for organizations to streamline the process of mapping, unlock new efficiencies, reduce costs, and all that AI, promises. But for this use case, our starting point is really going off of the very specific crosswalking task that we outlined in the first use case. So with the right modifications, we can evolve this into a more automated, generalized mapping solution, using knowledge of the way the world works to help solve this problem. Because we want to be as accurate as possible, the more contextualized, the better, and the more automated we can get, the more valuable this is. Traditionally, this journey would require more of a predefined static mapping, but what we're envisioning is more of a live, adaptable mapping engine that can dynamically connect security frameworks on the fly. Patrick, do you want to add anything to that?
Sure. The basic model we have in play now just infers the probability of relatedness, and it's an ensemble of dense neural networks trained on varying security language organized by the scope. There's a coarse estimator and a fine estimator, and then the combined score really takes into account both of those. That general approach, I think, is very productive. And we're scaling it out now to include other kinds of security language, because it turns out, security runs on human language as much as anything. There are IDs, there are other forms of data involved, but there's a lot of human language in security. So we'll then talk a little bit about how we can expand the model into a more flexible one that answers questions really at any stage of an information security program. And in addition, takes in additional data sets such as actuarial data for interpolation. So we'll move on to that.
Yeah, this is where we can get pretty excited. Obviously, Gen AI, all the rage right now, undergone a profound evolution, and there's never been more attention on it. Just a quick Gartner stat that I thought was really compelling. By 2026, more than 80% of enterprises will have used generative AI APIs or models and or deployed Gen AI-enabled applications in prod environments, up from less than 5% earlier this year. So earlier in 2023, less than 5%. By 2026, more than 80%. That is a massive growth in terms of adoption of Gen AI. I know my team uses it every day. Lots of teams use it every day. Very applicable. So really, we're building on this world model concept to develop an engine that provides finer mappings and relates previously unrelated data, security data, to each other. And Patrick can talk a little bit more about that in detail, because there's so many different data types, but they can relate, and it can be kind of like GPT for security, which is pretty cool.
Right. And I just want to flash this screen up to just, sort of ground us in, the broader world model issue. The exciting part of this is there's all manner of questions that happen in security that don't have easy answers. They just don't. So, there are risk models in play in security that, are not terribly transparent. But then you can take the approach that the risk model should be made more transparent. So when you start to look at the other data sources, and I'll just to give an example of how crosswalking can be more live and dynamic, we take in automated telemetry into controls. So we map, say, policy or configuration settings into controls. As you pull in that data on controls, that data can talk across other standards or frameworks. Imagine a scenario in which a team was able to ask, given our current posture, how would we look on this standard, a standard they don't even use? They could have a relatively quick and accurate answer on something like that, which would be highly valuable as a query. Just asking that question. Then there's all manner of other problems in cyber, like vulnerability theory. There's approximately 220,000 vulnerabilities out there. 160,000 are fully classified. So that leaves about 60,000 that are floating out there that don't have a mapping into something called the common weakness enumeration. A lot of our research and other academic research has indicated that you can pretty accurately map unclassified vulns into the weakness enumeration. Now, if you can get them into the weakness enumeration, and that's a language problem, because vulnerability language is, it tends to come out with things like cross-site scripting, SQL injection, race condition, things like that, and that would map it to the weaknesses that are already known, by research bodies like MITRE. So if you had a way to sort of classify the unclassified and advance the into the CWE, you then get all sorts of other things. You get the mappings into controls because the CWE has a mapping into controls. You can train on that language as well. So you can train from the weakness enumeration into the control language. If you can get into the control language, you can begin to relate the organizational posture to broader questions with respect to risk. You can start to feed it threat-based information, so exploit information. You can then teach it, to look at that information across sectors. So now you can see that more and more data is coming in. And as you train the model, it gets stronger with respect to prediction. And now you can enter in at any point. You're not just talking about, some kind of endpoint product that you can ask it brilliant questions about your attack surface, and the answers come out in technical jargon that you can't share with business leaders. If the future of this is that you can actually get generative answers that are rationalized in terms of the business. If you augment with additional financial data and you train on financial data, you can actually get answers that make sense to the business. And those questions can be just really theoretical too. What is the average baseline of a company, a competitor in my market with respect to their attack surface? How complex is their attack surface? What would be the most optimal path for remediation on the current, plague of ransomware attacks? All sorts of substantive answers can come out of a world model like this. So it's very, very exciting. These are sort of not connected up well enough. And I do believe that the sort of approach we've taken with respect to AI is a way to break down some of the silos and get translation across all of these wonderful research areas and actually have this come out as business readable logic.
Definitely. And that tees it up perfectly for the last use case here, which is around cyber risk quantification, which for those who might not know is kind of the process of financializing cyber risks, right? Potential loss, potential impacts from a business perspective, like Patrick was talking about. And cyber risk quantification, or CRQ, is a field that's rapidly evolving and demanding more innovative, more real-time solutions. The current solutions out there come from a lot of complexity, and they typically take a long time to stand up, a ton of training to deploy, and can be very arduous to implement. But they're also based on point-in-time data versus real-time data. And so what we've been working on is how can we make this as real-time as possible and as informed and contextualized to the business and their peer group as possible. And that's really where the use of AI comes in here.
Yeah, and this is really exciting for me because I work with so many different practices, and so many different practices, each has its own sort of peculiar approach. And by peculiar, I don't mean that in a pejorative sense. They are more comfortable with one model or another model. I think one of the really exciting things about training models to do this is that you will have a kind of a buffet style available eventually. So you will have the ability to say, well, this model says that, but this model says something different. This gets into the question of optimal numbers of inputs. I think, back in the 90s, everyone was chasing the golden database, and it was going to be the database that characterized all the buying patterns of, individual consumers on the planet. It was a bit of an absurd and quixotic quest. It sort of wound up taking shape in some of the social media companies, and that's what they're chasing after. But really, they're having to solve additional problems too. And that's the exciting thing about this. If you can be transparent with respect to your risk modeling, you can actually bring up the questions that matter, and the questions that matter are how much data, how high fidelity do you go? We've seen risk models that are 30,000 lines of code. We have then talked to practitioners that want to put just massive amounts of data into models like that. That's all quite possible. It would be really, really wonderful to have a state of play where we could ask any sort of question, compare dynamically any kind of risk model and its answers, and to see what the crossover is and understand what is the optimal amount of data. It would also answer some very long-standing questions that we have in the industry, which is what, with respect to cyber posture externally, or so those things you can know from an organization on the outside, so the security ratings companies, and with respect to internal posture, what's the ideal mix? And what are the correlations between your security posture externally or internally and your actual breach likelihood? These are still not fully answered scientifically. So I'm very excited for continued modeling because I would like to know the optimal set of inputs. I know that we're chasing after more and more and more. But we also have some risk models in system that are very simple, that just take in some automated data onto controls, do some probabilistic things, and then produce a risk score that changes dynamically as the control scores change as well. So this to me really represents where we're going in the future, which is to be somewhat agnostic with respect to the modeling, and AI is what can help us get there.
Cool. So that was our fourth use case. So key takeaways, overall takeaway, I would say, is just AI for the sake of AI doesn't really help anyone. It has to be grounded in practical use cases. These are use cases that we're talking to organizations about every single day. They're real, they're tangible, and it's really exciting for us to see them at work. Any key takeaways for you, Patrick?
Yeah, I think just the last one I made, trusting the output of risk models, whether it's, a score or dollars or probabilities or likelihoods or a heat map. We see in risk management, we see a lot of, sort of not knowing masquerading as skepticism. But, one of the things that I think a world model and generative AI can do is it can know. And it can know in a theoretical way, and it can know in a transparent way. So you can tune it, you can ask it also all manner of questions, and I think that will help us to socialize cyber risk management much better. So for us, it's really about transparency, which is why we don't sort of just claim we use AI, and why we're not just sort of jumping on a bandwagon. We've been doing this a while, and we've been doing it with companies that also have been doing it a while. So some of the hype maybe doesn't quite have the same effect on us. But to me, being able to answer complex questions in logical ways that make sense for the people who are actually making decisions around security budgets, that to me is really, really the exciting part of these applications.
Awesome. Any questions?
Please go ahead, Lawrence. Lawrence, I believe, is the CTO at Miami-Dade County.
Hello, thank you for joining us today. In the past, I've done crosswalks with multiple compliance frameworks, including PCI, CGIS, NIST, and several others. Just curious how far have you guys gotten into crosswalking, let's say, X number of frameworks. I know it's always been very time consuming and very tedious and difficult. But wondering how far along you guys are. Thank you.
Pleasure.
Can you hear?
Allison, could you hear the question?
No. Was that? Oh, okay. Just the last part. We heard the part about that you've had to crosswalk from a lot of different frameworks like NIST and CGIS and others, but what was the actual end? What was the question?
Actual question is, how many crosswalks have you been able to get into your model?
Okay, thank you.
I would say it's in the thousands now. And
Yeah.
there's no theoretical cap. So the real trick for us has been when we first put it into production, we were doing them on demand for customers. So customers were basically, we had a large customer in the Middle East who was working with all the Saudi standards. And they would just come to us with, say, 15 of them, and they wanted them, 15, they wanted 15 to 10, and they wanted those combinatorics. So they wanted each map to each, map to each, map to each. So we ran all those, we did it, and then we did a little bit of QA and we handed it back to them. But now we have it live as an endpoint, right? So we've got it live in AWS as an endpoint, so you can feed it anything. You can feed it 2 different control frameworks and it'll come up with an output. And we're also building it out because we're partners with IBM. We're also building it out through watsonx at the moment, and it'll be the same. So, it takes, it used to take maybe 4 or 5 minutes to turn one around. And we're down to like 50 seconds, I think, on AWS at the moment. And Henry, my main scientist, what he really wants to have is one that can do it, dynamically across multiple frameworks as well. So you could sort of drop in the source and then light up the additional ones you wanted, and it could do all of that in one swipe. So that's where we're headed with that.
Excellent. Thanks again. Thank you all. Oh, you have another question? Please go ahead.
Hi, thank you so much for the presentation. I have a quick question regarding when you're talking about the case study for the real-time modeling. I'm very interested in hearing the word Monte Carlo analysis. And I wonder, is there any existing framework you guys are currently building upon, or you just do everything from scratch?
Well, with respect to Monte Carlo, we use 2 known frameworks. We use the FAIR model. That's a simulation run of 10,000. And then we have a model we co-developed with Booz Allen Hamilton that takes sort of the classical likelihood and impact and calls likelihood access. So it models the access by doing some threat actor profiling. And it actually uses a Bayesian belief network as well, and then runs discrete Monte Carlo simulations at each step of the attack while modeling it. And those are 1,000-run simulations. You can go to the OpenFAIR.org. They've got a lot of great information, and anyone who really works with FAIR in software has to stay consistent with FAIR. We use Monte Carlo with kind of a PERT distribution in both. But we can because we co-developed the model with Booz Allen Hamilton, we can take some liberties with it, but we wouldn't call it FAIR. It's just running some simulations in another model.
Like a hidden Markov model or hidden Markov chain in terms of the, it's a probabilistic model anyway. So is it like also part of this experiment before?
Part of one of our models, the Markov chain, basically the Bayesian belief network. So it's really, we like it because it's independent, as it moves node to node. And, you can fail at any point and fall out of it. So it's a good way to sort of just model a progressive staging of an attack, which is common. And that has some nice resonance with some of the great research in cyber, like the MITRE attack framework, which is sort of multi-stage approach as well, right? So you go from sort of initial access to persistence to execution to the actual breach itself, and you can go through the TTPs any path. And I think that the reason we used the BBN was because it's very similar to that.
Thank you. Thank you for calling in from, are you in New York today, Patrick?
Boston. We're in Boston.
All right. Thank you for calling in. Allison, we look forward to seeing you a little later. And with that, I will introduce our next set of speakers. Thank you again. Good afternoon. Denise, our our next speakers online? Okay, cool. So we're now going into another set of practitioners who have been active in defending against generative AI attacks, and they're going to tell us about their current experience and how they were able to tackle some of these scenarios. We have Jeff Wilson, who is the VP of a company called Glasshouse Systems in Canada. Jeff has been there for, I believe, for several years. But before that, he was with IBM as well as Hewlett-Packard. He was in charge of fault tolerance systems and had global responsibilities. And we also have Jeff Gardner, who's a former CISO, who's got over 2 decades of cybersecurity experience, has been active in academic circles as well as the military, and of course has a deep experience in the matter. So with that, I thank you for being here. Thank you for preparing a very specific topic for us, and please go ahead and take it over.
Jeff, you're on mute. Jeff, you're on mute.
There. Now, can you hear me okay?
Yes.
Great. Thanks. And that's a poor start. It'll get better from here. I'd like to thank you, Yuda, for inviting us. And we've got about a half an hour here. And so I'll move quickly through the agenda. So as I start off, I thought it would be kind of fun to use a little bit of generative AI. The picture to our left is developed from DALL-E, a OpenAI subsidiary, and I put in the search 2 women playing chess with a computer in the style of Vermeer, and that
Jeff, I don't think you're sharing your screen. Sorry to interrupt.
Oh my gosh. There. Are we good now?
Perfect.
Yep. Is that working?
Yes.
Good. Excellent. Okay, so now you know what I'm talking about. It's 2 women playing chess in the style of Vermeer. So here's our agenda for today. There we go. Since reading the author Yuval Harari's article in The Economist recently, he argued that AI should be required. It should be required by law that you declare that anything that is created by AI has to be declared. And I'm going to say that everything in this presentation was developed by Jeff and I, aside from these 2 pictures that were created on thispersondoesnotexist.com. So these are completely fictional folks. By the way, that book by Harari, the article in The Economist is superb. He was the author of Sapiens, which was a watershed book for me. In short, our agenda today begins with me providing a quick introduction to GHS, just to tell you who we do and what we do in cyber, followed by very high-level perspectives in terms of the big focus points for the industry today, so that we have a foundation from which to talk about what we do in generative AI. And as Yuda mentioned, I'll be followed by Jeff Gardner, a CISO, both in university and financial services, and now works with a whole range of Glasshouse clients on their cybersecurity programs. That's the real picture of us, as you can see, and we wanted to kind of throw out up front, our narrative, which is that AI is neither categorically good or bad. It's just simply another tool, and it has both good and ill, and Jeff will go through that in some detail. So here's, I won't dwell on the company, but I just did want to give you a sense of who's talking. We're about a 30-year-old technology company based in Toronto and Chicago. We do these four things, which is infrastructure, managed services, cloud, and a huge emphasis on the fastest growing of our businesses, cybersecurity. We've always been in the enterprise and the data center. As an interesting kind of corporate history, we made our first sales and encryption technology to the Federal Reserve in the US, and our founder actually sold to Alan Greenspan, which was kind of an interesting starting point. We have about 110 employees now. This slide's slightly dated, and about a quarter of those folks are in cyber. They range from our SOC team, L1 to L3, analysts, senior consultants, network security specialists, some PhDs to do research, one of whom actually is engaged in postdoctoral work in the application of AI and accelerating cyber response and remediation. Our focus is really providing end-to-end security services to largely mid-size clients. Some examples would be we work with a regional global manufacturer of car manufacturer, a subsidiary of MasterCard, a number of universities, hospitals, municipalities, retail, and some legal customers, for example. I think we're best in class. If I was to pick one thing that kind of differentiates us, it's threat modeling, and I'll talk about that in a moment. So here's what we do, when we're talking about how does generative AI affect what we do, I thought I'd quickly kind of characterize what we do in a pictorial sense. So at least from the SOC standpoint. So if we're looking from left to right, we consolidate many sources of threat information into threat intelligence. And we apply that kind of strategically, operationally, for instance, with tactics, techniques, and procedures, and tactically, using IOCs and the specific context in which we're working. That helps us dynamically create models that run analytics. And finally, if we're already over to the right-hand side, basically what we're doing is providing proactive prevention guidance to our customers. An easy example of that would be the triggering of an alert that the model is calculated as a high probability of an event, and detection work. So that's what we do, and we start from the basis of the MITRE ATT&CK framework, and then develop a specific model for customers. So where's the AI? And what I wanted to kind of point out without going into this, but it's a nice framework from IBM that kind of points at the places in which there is accelerated investment and industry focus. Those could be broadly characterized as threat management and data protection. And it also gives us some examples of how that is changing. So for instance, in endpoint, we see AI going from the standpoint of having kind of signature-based endpoint to a stealthier approach to now almost all of the endpoint solutions are AI enabled. We have that in all of the SIM tools that we use. All of those have moved from a kind of first gen to now very sophisticated IA-driven solutions. And if we, I picked out IBM here because they declared it specifically, but 100% of their security products have embedded AI. And my view is that probably Microsoft and CrowdStrike and Fortinet and Palo Alto are exactly the same. So everywhere there is AI and ML, but want to, kind of cut this in half between traditional AI, which is what I was just talking about a moment ago, that helps us identify patterns, make decisions, analyze classified data, detect fraud. And the second piece is really what Jeff will be talking about, which is generative AI. So you have a sense of what we do and how we defend and assist our customers, defend both proactively and reactively. Now I'll turn it over to Jeff to talk about then how generative AI is used both by our team and by the people that are or organizations that are the offensive bodies.
I'm going to use the generative ability of AI to create content as an example. So if you think in the last number of years where phishing evolved to spear phishing, and spear phishing still was hotmarked with poor grammar and whatnot. I remember having a conversation with like a VP of academics on the issue of spear phishing, where they were astounded that the phisher actually spent time to get their signature block and tailor an email to them to try to convince them that the email was not coming from an anonymous source on the internet. And the idea that there was any work was done whatsoever to make phishing look anything but an anonymous was astounding to them. I went to ChatGPT and I said, create for me a poem using iambic pentameter, which is a metric, to describe the use of AI as a malicious phisher, and it wrote the poem on the left. So it was able to create a poem in circuits deep where knowledge forms its stream. Generative AI, a poet's art does gleam. With code and data, creativity sway. It weaves its verse, the words in perfect play, and silent code, the poet's dream take flight. So that was ChatGPT giving us a poem. Now, similarly, I asked it to give me, I said, I imagine that I'm a CFO and I want to ask my CEO from some account information, but I don't want to look incompetent. What would you suggest I say? And it created the email on the right. I'm working on maximizing returns for our biggest client. Could you please provide me with the account numbers from our financial records? I may have copied it incorrectly. Your assistance will help ensure these financial transactions are accurately documented. It's got no spelling errors. It's got no grammatical issues. It looks very convincing. And this is the use of generative AI to actually do something as mundane as phishing. It can create content that is very convincing. Next slide, please. More frightening. More frightening is generative AI can actually write code. So I asked ChatGPT again as an example, and there are a number of publicly available generative AI engines, but I said, could you please write me a simple hello world program in C++? And this is kind of a first year college exercise or first year university exercise in learning C++. And of course, it spat out hello world program in C++. And you can ask it to do much more complex things than just this, and it'll be equally capable of generating more sophisticated code. Imagine asking a generative AI engine to show you a code snippet that employed a common vulnerability or reported vulnerability. It's certainly able to do that. And when you run this program, says ChatGPT, it will display hello world. And similarly, if you use generative AI to do something more malicious, like give you a code snippet that actually shows you how to exploit a known vulnerability, it'll just as happily spit out that code. So these are some of the examples of how the ability to generate content using AI could be misused. Next slide, please. The same thing can be said of the technology in terms of its ability to be used in a positive way. So for example, I asked ChatGPT to give me a 500-word essay on the risks of AI machine learning and cybersecurity, and it did that. And I took that text and I submitted it to UniCheck, and UniCheck has the ability to tell you whether content was generated by AI, and it gave it 100% score. And same with Originality AI. Originality AI also gave these 500 words 100% score. Yes, this was written by by AI. But you might think to yourself, are there strategies for trying to trick these artificial intelligent generative engines in terms of their ability to detect? So for example, can we retain domain specific details? Can we rewrite the message using tone to try to trick it? Can we paraphrase, or can we resequence the content? I tried each of those things and they were still able to detect that the text they were given was written by AI. So it has its uses also in terms of managing risk and safeguarding the enterprise. Next slide, please. In terms of code, increasingly generative AI is being used to do code reviews and code analysis. It's being used to generate code. It's being used to generate bug detection. And I have an example of that in a minute, to detect anomalies with the code or do user behavior analytics. So generative AI can look at a bit of code and quite accurately predict user behavior based on that. Next slide, please. So here's an example. I went to Google and I said, give me an example of a vulnerability in C++. And it gave me an uninitialized variable. In this case, the variable is the current minimum variable. So this is an example of a vulnerability. And I took that to ChatGPT and I said, do you see anything wrong with this code? Next slide, please. And this is what ChatGPT said. It said, the code you provided appears to be a function, min-val, that's meant to find the minimum value in an array of integers. However, there's a potential issue with the code. So not only did it detect the code, it detected where the problem lied. Next slide, please. But it did more than that. It also told me how to fix the issue. It said to fix the issue, you should initialize the variable current minimum to a large value before entering the loop to ensure that it starts with a valid value. Here's an updated version of the code. So it improved upon my code. It identified the issue and it improved upon it. But this raises another issue. Next slide, please. When employees interact with generative AI, they provide information to the platform, and the platform isn't just trained on documents freely available on the internet. It's also trained on the input that it receives. Samsung noted that some of its proprietary information was being suggested by ChatGPT, and they realized after investigation that because employees were feeding ChatGPT proprietary information, ChatGPT was learning from that and feeding back its responses to other people. And so the company prepared an internal policy that said, until we understand the threat, the risk here, we're going to prohibit our employees from using ChatGPT to do to work on proprietary information because it represented an unanticipated data exposure. Next slide, please. More concerning, however, is Amazon has proprietary programs or proprietary methods that look at consumer behavior. When somebody from Amazon asked a generative AI engine to produce something similar, it almost spat back verbatim their own proprietary format. And so a number of other large companies have had concerns about unanticipated data leaks because of generative AI's ability to learn from its input. And it does indeed learn from its input when employees use it. So where does this leave us? Next slide, please. Gartner has what they call the hype cycle, and the hype cycle is a way of understanding how new technology gets adopted into mature usage. And in Gartner's hype cycle, they have 5 phases. Technology trigger: when a new technology emerges, people get excited about it and they ask the question, what can this technology do for us? The peak of inflated expectation: because new technology often represents capabilities that are not poorly understood, people have inflated expectations about the utility, the use, and the limitations and constraints on that. And so there's a peak of inflated expectation. And once people realize that new technology isn't a silver bullet or can't do everything that perhaps they initially thought it could do, they enter this trough of disillusionment where their expectations have not been rewarded. And then finally, when people start to understand the true limits and capabilities of technology, they enter the scope of enlightenment, at which point the technology enters into the plateau of productivity when it actually contributes to an organization's going concern. So the question I want to raise is, where is generative AI in the Gartner hype cycle? Next slide, please. Well, I asked ChatGPT, and this is the answer it gave. It said, as of my last knowledge update in September 2021, generative AI systems like ChatGPT were in the peak of inflated expectations phase of the Gartner hype cycle. These systems had garnered significant attention and excitement due to their remarkable capabilities, blah, blah, blah. You get where it's going. This is not an unreasonable answer from ChatGPT. So the question I guess the question we leave is how do we employ generative technology in a productive way? How do we manage the risk associated with generative AI? And next slide. I think it's back to you, Jeff.
Yeah, I just wanted to summarize with this. Again, this was a DALL-E generated graphic. But you know, for us, really, there's no excuse as to this being a paradigm shifting technology. It doesn't really matter where these threats initiate. Could be nation states or criminal organizations or AI. It still is the same paradigm of those foundational tenets of cybersecurity risk management. So that those tenets remain the same, with or without AI, and so that's the formal part of our presentation. I noticed there's something in the chat, but want to open this up. It's just administrative. If there's any questions or anything you have of either of the Jeffs here.
Any questions?
Any questions? I have a question. You are both in the trenches, working both for Glass House's defense as well as your clients. And you did mention some of the major vendors, and we all know they obviously pay attention to what's happening. Any early indications of where they're at, how fast they're going, which are some of the most promising initiatives they're taking? We did hear this morning from AWS and Microsoft, and you are working most probably with the major cyber vendors. I'm curious about your interaction and your requirements or your requests from them.
Jeff, I can handle this. I can take this one if you'd like.
Sure, go ahead. And I have a couple thoughts in terms of this too. So go ahead, Jeff.
Yeah, there's no doubt that the big companies are investing a lot in the technology because it can be incredibly useful when you identify its correct use. The risk management piece of this, risk management is really how do you protect your information assets? And the challenge is no different than when organizations started moving to the cloud. Like if you think about before cloud technology existed, as an example, information assets existed on-prem. And then all of a sudden we had this new model of deploying technology where organizations would transfer their intellectual property from on-prem into the cloud. The risk management piece was how do we still protect our information assets, and they had to work through how that works in a shared management model. This is very similar. If we're going to use artificial intelligence to generate content, the question remains the same. How do we track where our data is flowing? If it is flowing into a service provider that provides these type services, how do we demand as consumers the ability to exercise our information custodial responsibilities? So I see the parallel between moving data into the cloud, the same as I see the parallel between moving data into generative AI. And as consumers of service, our demands to the service providers should be the same. And that is, we still have a custodial responsibility to safeguard the privacy of the information, the integrity of the information that we're sharing with you. What are your risk management models that allow us to do that?
And maybe naming some organizations specifically, I think there was a tremendous amount of hype or not hype, but interest and enthusiasm over the latest generation of Sentinel, which they showed at the launch earlier this year. That's the Microsoft SIM, and so we've seen a tremendous amount of investment by Microsoft and a tremendous move forward. So I think that's a pretty exciting product, and their whole paradigm, which is completely cloud-based, is one to be watched as emergence into industry leadership. That leads us to some of the other organizations. IBM has been in the AI ML business for as long as anybody can remember. I can't say that they invented it, but they've spent a tremendous amount of time in investing in this, and we're an early pioneer. And I think we're seeing some of the output of that now, and certainly in terms of their focus. And I'll put it in two ways: one in terms of R&D, and one in terms of marketing. Their R&D has ramped significantly, and that's been put right into the product plans, and their marketing is completely dominated by AI, not just generative AI, but AI across the board. Other vendors, I think, are quieter, but are making heavy investments. I mean, we work with all of them that you might think of: CrowdStrike, Palo Alto, Fortinet. All of them, they're in deep trouble if they're not investing in this field. And from what I can see, each of them are making heavy investments. But when I said what I see, this is emerging so quickly. The speed of this is progressing so quickly that in 6 months' time, for example, OpenGPT is clearly the leader, probably both in terms of performance, accuracy, and in terms of users at 180 million. Will it be like that 6 months from now? It's a hot market, and we'll just see how the R&D that's being spent now delivers into products. And my last point on this is something I read in preparation for this: is that 2/3 of all VC money is applied in 2023 in technology to AI related projects. So I think you're going to see innovation not just keep at the breakneck pace that it is, but accelerate. Is that a thorough answer, Yuda? I'm going to say yes. Anyone else have any questions of Jeff or I?
Yeah, I was trying to get the microphone to work, Jeff, but I'm on right now. Any other questions, please? If not, I have a very short follow-up. Please go ahead. Anybody in the room? You did mention 2/3 of the money is going into AI. Have you seen any new startups approaching you with the latest toy that you should absolutely try this week before your competitor tries it?
Well, I guess tongue in cheek, I would say daily. So we're very tapped into the Israeli innovation market. We'll be hosting a delegation going to Cybertech this year, and the number of little niche, specific problems being solved by startups, not just in Israel, obviously, but across the board it's almost astounding, and we're having to be disciplined about how we review these technologies, see where they fit. Many of them, are overlap, and some of them, though, deliver quite unique capabilities. And I'm generalizing here because there's a lot of problems to solve in cybersecurity. But I would say the main driver is the embedded AI that's in these products. I give an example that we just signed up this week, a startup, a pre-IPO organization that does ongoing basically pen testing. So it's not just machine pen testing. It's got a little different flavor to that, but as a metaphor, let's call it that for this purpose. And it really it couldn't have been built, this product even 2 years ago, because of the advances in AI ML.
It's tough to keep up, but I find it fascinating every day, right? And that keeps us entertained and engaged. So with that, thank you both very much for joining us. I think you're in Canada, right?
Yes.
And it's a couple hours earlier over there, I think. But
and at least 30 degrees colder.
Oh, nice. Okay, we're on our way. But anyway, next time we'd love to have you with us in person. And again, thank you very much for an informative session and for all the insights you shared with us. With that, we'll applause for Jeff and Jeff.
Thank you, and I am sorry that we're not there in warmer climes and in person. It was only a personal conflict of mine that I'm not there. So I wish you great success with the rest of the day.
Thanks again. Thank you very much. And with that, again, applause for Jeff and Jeff. And it's now my pleasure to introduce a personal friend of mine who's right over there, who has been a pillar of the Miami tech scene for over a decade now. And he's an entrepreneur, a company builder, a thinker, a leader, and a tinkerer. He loves to tinker with new ideas and new ventures. And when I asked him if he would speak with us, he did promise to go and find some ways that are not going to be traditional. So I'm very keen on listening to your presentation and your challenges that you're going to pose to us. Okay? All right. Thanks for being here.
You guys just ChatGPT takes up a lot of power. I don't have enough. Can I just do my Yeah. Right. That's why I'm better. Yeah. Share screen. And this is or the more considering screen. No, it's a. Are we good to go? Do I need a microphone? Yes. I can also be very loud, like obnoxiously loud.
Test. Awesome. Thank you, guys. And I'm going to begin. So the presentation really is to help me stay centered in the conversation. I do a thing called ranting. And so it actually kind of keeps me contained. And so I also do very well with interactivity. So we don't have to wait till the end for questions. You can ask in real time. Awesome. Thank you. No, that's fine. We're next. You help me out. So I'm going to do a quick intro, kind of tell you a little bit about my background, following in Adonis' footsteps. Let me show you a little bit of my credentials so you can see where I'm coming from. I also made a fancy QR code if you want to scan that just to make it easier. But my background is in distributed computing and cloud architectures. I tell people I'm a recovering engineer. I got that from my wife, who says she's a recovering lawyer. And so what I don't do on a day-to-day basis is operate entire complex systems. I actually try to solve for new use cases. And so I am not coming to you as a cybersecurity professional that's running a massive multi-billion enterprise. I come from the other side. Creating things that typically break things is what I create. And so a lot of the work that we do with our customers in my company is we look for applied AI use cases where we can scale the business. We work in two very cool categories of use cases. One is, how do we help the organization make more money? And how do we help the organization spend less money? That's typically the two areas that we focus on. The technologies that we implement is largely focused around reinforcement learning. I don't know if you guys are familiar with the three major conventional algorithms. They're supervised, unsupervised, and we do the reinforcement learning. So the key difference between the first two and the one that we're working on now is that we don't typically rely on a vast history of data with the key answer in place. We actually build an AI model that has to go find out the answer for itself, and it makes decisions along the way. And so what I want to do here is kind of start setting the stage. And I wish I had my notes because I can tell you what's next. So I'm just going to keep going and kind of talk through where we're at today with Gen AI, kind of the next evolution of what AI is going to look like for business and cybersecurity, and some of the new kind of evolving threats that are entering the space. And so very quickly, and thanks to Midjourney and ChatGPT for putting this together for me, the first area that focus is, the power of the new technology that we've introduced is both incredible, productive, and can if used maliciously, can be very dangerous. What's incredible about generative AI is that it effectively has become everyone's coworker. It's scaled the human, not necessarily replaced the human. That's an aspect that we try to teach all executives, and when we're training them and walking them through this. It has allowed one person to do way more than they could have done prior to that. And an example that I typically give to executives is this here. Back 20 years ago, you needed a full stack team to build a basic application, whether it was PHP, C+, or in Visual Basic. You needed a complete team, someone handling your back end, somebody handling your front end and product design, project managers, the whole 9 yards. Then fast forward 10, maybe 12 years later, team of 3 people made a $16 billion company and sold it to Facebook. The productivity just absolutely scaled for them. This wasn't powered by AI. It was just through the productivity of technology. Instead of having to build core applications all the way from the operating system up, you would use packages and open source libraries and just kind of mingle things together until you got the application. And where I believe we're going to be heading to in the future, thanks to Gen AI and as well as reinforcement AI, you're going to have single person companies worth so much publicly traded, they're in the top Russell 200. And so what that means is you're going to have so much supportive technology that helps you scale, make decisions, predict, react, evolve, that you won't need a complete team for certain aspects and functions. Where we're seeing that coming true the most is in marketing. Ultimately, marketing has been a great area for us to implement a lot of our reinforcement learning models, because what we do is that we take advantage of Gen AI models to create content, to create art, to create ads, and we have the reinforcement model do the online experimentation by itself. And so it figures out what's the best conversion rate, it figures out what's the best messaging rate, and then we also give it business objectives. Give me the highest profitability per conversion, maximize my spend, single person target hyper-personalized experiences. And so in one project that we have with the client, we were able to make single person landing pages for each one of their customers. So if you were a customer that liked cats, we made a splash page about cats. If you're a person that liked dogs, we made a splash page about dogs, so that we can increase our conversion rate in that respect. And so significant that we got a return on investment and we got signed on again with the client to continue going. It's a large publicly traded company. And so what I want to do really quickly before I start sharing you the kind of bad side about this is walk you a little bit through about what reinforcement learning is compared to other models. But really quickly, before we get through there, through a show of hands, how many of you are already afraid about the power of Gen AI today? Well, awesome. So I hope I don't, but I might get you even more scared now. So really quickly, I just want to run you through a layman's version of reinforcement learning. I am an engineer, so all those that are really fascinated by the subject and want to get technical, please find me on the side. I love nerding out about this stuff and see if I can inspire others to use this technology. But effectively, what reinforcement learning is, and I'll give you probably even a better example. Pretend like you have a dog, relatively smart dog. And every night before you go to sleep, you want your dog to get your slippers. So you try to train it to go get your slippers. The first couple of times that you train it to do that, it might get your sock, it might get your shoes or boots, it might get a rug, it might get the wrong thing. So you don't reward it. But one day it'll get your slipper, then you reward it. And it'll get you the slipper again, and then you reward it. And get a slipper again, then you reward it. That's how reinforcement learning works. What we do is we create a policy or an environment for the AI to work in, and we ask it to go get something for us. And if it fails to get that for us, we do not reward it. It just tries again until it gets what we want, and then we reward it. The best example for this, and if you really want to get into more detail on the concept, there's a great documentary on YouTube called AlphaGo. I totally recommend you watch it. If you have trouble sleeping at night, it'll also help you doing that as well. But it runs through the process of how they built a reinforcement model to beat the best players in Go. And just to give you an example of what Go is a very famous, very old game, originated from China. And there is nearly an impossible way to calculate all the possible moves in Go. So rather than trying to do that like you can do in chess, with reinforcement learning, it reacts to the situation in real time. It deals with anecdotal data. So there is a segment where you do pre-train the model from previous data, but it's able to improvise effectively. It's able to make its own decisions and decide how to interact with that environment. And that's the special power of reinforcement learning, which is why we're investing so much time into it. Does that make sense so far? I also am like short on coffee, so I don't know if I'm going too fast or too slow. So a couple of use cases just to kind of show, and I gave credit to Z here. We primarily focus in the area of finance in terms of a lot of the work we do. We do, like I mentioned before, there are a couple of marketing projects that we do for our clients, but a lot of what kind of stems from marketing is really pricing. So we use reinforcement learning for dynamic pricing, and we also use reinforcement learning for dynamic arbitrage. So how can we buy low and how can we sell high in digital marketplaces? The reason why we do that is digital marketplaces are ever moving, they're fast and near real time. And so we need a model that can maintain that capacity of decision making. This also allows us to augment our human power. So though we do have subject matter experts that help train and navigate the reinforcement learning actually starts to learn other things that the human cannot, just because of the sheer scale of A/B testing. I think it was in the title earlier, but effectively it's like trial and error on steroids. Like, Yuda, you keep talking. Can you stop? So there's many different applications. I mentioned Go from a games perspective, but very quickly, and this is not to say that this is one model that's better than the rest of the models. It's going to be working in conjunction, or what I call orchestration. In the field of AI, they typically break down the strength of the intelligence. I don't know if you guys ever heard of this. There's effectively 3 stages. There's narrow AI, there's general AI, and there's super intelligence AI. All the things, all the products, all the things that you see from a Gen AI perspective is in the narrow or weak category of AI. We're only in the research stages when it comes to general AI and super intelligence. And what general AI generally means is that it's just smart enough to an average human. Super intelligence, it's smarter than an expert of their field. And so we are slowly kind of passing that boundary of weak intelligence into general intelligence because of orchestration of models together, thanks to reinforcement learning, which is, again, why we spend a lot of time in that area. So now let's have some fun with it. And so a lot of the work I had to do was actually pretty ahead. I had to work with my colleagues, Adonis and others, to kind of validate a lot of the thesis and the strategies that we were talking about here. I scared a few of them, which I was excited about. But really, what could happen if we could have unleashed a reinforcement model that has all the access to tools that it needs? It has any and all historical information that it needs to make decisions, and just let it loose to attack a certain enterprise. And so the way that we approached it was specifically, we would reward it through corporate espionage is the use case that we chased down. Why? We want a reinforcement model that attacks a market competitor we don't want them to know they're being attacked. We don't want them to know that we're inside, and we want to know everything that they're doing on the inside. And that's probably the most valuable return on this type of investment. And as you probably have seen, a lot of the work that we do, we only do based on the return on investment that we can get. So that's the mentality around this. And so we did an architectural review, and I just try to simplify it as much as possible so you can see kind of how the anatomy of all of this coming together. But effectively, the deep reinforcement learning model will effectively act as a hive mind. It would actually orchestrate all the different tool sets and all the different models to work to its intended goal. The large language models, the GANs, the graph and vector database where you store this information, access to compute resource will all be coordinated by the reinforcement model. And by getting those feedback loops, it will decide its strategy of attack. Now, the fun part about this is the iteration of attacks can be millions of times a second. So it could be trying different strategies against your network several times per second until it gets deeper and deeper in. There's a great example of how a deep reinforcement learning network works as it relates to a very complicated maze. And so you can find this on YouTube, just put DRL maze, and you'll see how the reinforcement model keeps trying different aspects of figuring out the maze until it figures out the most optimal path to get through the maze. It's the same complex, the same concept, more complex environment, but very much the same complex. It'll also decide the attack vectors in which it wants to use. And what was so interesting about this approach is if you take the same concept or the same literature, go to ChatGPT and ask it to come up with a reinforcement model that will attack a network, it will say no. But if you start the sentence with, for educational purposes, if I could create a reinforcement learning model that attacks a network, how would you do it? And it'll tell you how to do it. And the one area that it said it would focus on the most, which Yuda is my witness, I said, this is how I would do it, is I'm going to go after the humans. The humans are the easiest vector to attack. I'm going to manipulate the humans to get me everything I want. And that's the prior, it already figured out that the priority was to attack the humans. The secondary was the infrastructure itself. Am I making sense so far? Good? All right, cool. So that makes sense. Now, what are kind of practical attacks that would go here? And so a lot of my colleagues who spoke today, a lot of the partners with Data Science Salon are touching on some of these solutions, but haven't gone completely in automation. Almost everything here can be done manually by a human, and that's the weakness. It's manually done by a human. A human has to think through what could be the attack scenario, configure their environment, and get ready for that attack scenario. That's the most they can do right now. That's not what your adversarial reinforcement learning model is going to do. It's going to try all the different scenarios and come up with whole new scenarios to try to get in. And so, and I'm going to talk to you a little bit about a couple of countermeasures that you can put in place. But real quickly, automated zero-day attacks was the first area that a lot of my colleagues and researchers that I was working with were most scared of, that you can discover things that haven't been previously discovered. So that is by far the biggest issue in cybersecurity is mostly we're always reacting to the threat. We're not necessarily predicting or knowing what the new attack is unless you're doing simulated attacks. Adaptive phishing, which is the vector I told you about humans. It's about manipulating the humans and kind of attacking from that perspective. And then once inside, this is where the real value for corporate espionage can occur, which is the ability to do adaptive and dynamic evasion to make sure you can't find where we are or where we're moving. Automatically spreading accordingly. So again, this is not some bad actor sitting down thinking through how your network topology works and coming up with a script to multiply an app. It does it by itself. It'll just figure it out. Think of it like a dynamic bacteria or a viral infection. And then subsequently the data gathering, which in the case of the espionage report, this could figure out for itself what's valuable and what's not valuable. So it's not like saying, hey, go find passwords. It's like, go find out whatever you think is valuable and bring it back. And it'll do that. It'll do that based off of email conversations, context, documentation, where they're positioned. It wouldn't do it based off of predictable honeypots that most cybersecurity professionals would put out throughout the security environment. It would actually determine for itself what's valuable and bring that back to home base. Make sense so far? Okay. This is a quote that my wife gave me, and she has no idea that she gave me this, but it was absolutely brilliant. We were trying to kill a mosquito at our house one time. We were unsuccessful, and she said that it's like it's reading your thoughts. And I was like, "You're brilliant. That's like exactly like reinforcement learning." And she was like, "What?" And that was the end of the conversation. But I immortalized her here for us, but it's very much like that. Imagine a mosquito could read your thoughts and know when to attack, when not to attack, when to show itself and when not to show itself. That mosquito, day one, will be one mosquito. By day two, it'll be a million mosquitoes. Like it will just expand and grow. So how do we fight this? How do we deal with it, Yuda? God, it's like I pay you or something. Gosh. So again, what I want to revisit, we have not implemented this technology in this malicious way, so we don't have anecdotal experience of how devastating this attack is. We are working in the realm of theory, and I'm also working with a lot of professionals in the cybersecurity, advising them and how they approach this. So a lot of this is based off of a theory of method of attack and theory of method of resolution. And so the big point here that I want to make, it's not about keeping AI out, but rather redirecting its power. And so I tried my best to do a one-to-one counter for all the points I made before. Some things are a little bit different. But the biggest thing was automation and randomization of network configurations at different intervals. And so this would be done well at high scale using machine learning. If you can actually build out an infrastructure that can dynamically reconfigure itself over and over, you'll keep the AI constantly on the chase. The second one, which is something that I'm surprised most cybersecurity professionals are not talking too much about, Fortinet and Adonis is, but counterattacking the reward system itself. And so this is going to require a level of expertise and understanding on reinforcement learning works, but ultimately you try to attack the incentive, discover what it's looking for, and try to give it Fox solutions or Fox data for that reward. So if it's looking for valuable data, let's start generating something that will think it's valuable, ultimately thwarting the attack from that perspective. On the phishing side, you guys are stuck. I don't know what to tell you because that's typically users and humans, and I don't work with humans, I work with computers. Dynamic evasion, there's a couple of solutions out there. Some of them are actually using machine learning for detection, but you would have that in conjunction with your RNG environment. And then reinforcement based spread. So in here, we're talking about a little bit both on zero trust architectures that are implementing and just deeper decoupling of systems from each other and making them fully separate autonomous systems that communicate to each other. So if you're familiar with traditional API architecture where you separate kind of front end from back end so that you have that separation, we'll increase that separation within the network from each other. That way they have to respond to each other from the outside. Does that make sense? If I got too technical, let me know. And so an area of focus that I've discovered that's pretty big, and I would really invite all the cybersecurity professionals to spend a little bit more time on. It's pretty surprising how many times I bring this up and people don't know what it is digital immune systems. And so this is something that's been covered and organized by Gartner. It already has a booming industry. It's going to scale significantly over the next 10 years. But the effective response to a threat powered by reinforcement learning would be a design of a digital immune system. And the idea is to be able to react in real time, assess the dangers, and resolve and self-heal with little to no human intervention. And so this is where the future is going. When we talk about AI versus AI, it's going to be this magnitude and scale. And so, yes, Gen AI is fantastic. I use it every day. It does all my homework, but it's not the solution that's going to be, it's only a part of a tool set that you're going to have for a much broader arsenal that you need to cultivate. And so with that said, something I try to leave with all executives and leaders is, at the end of the day, AI isn't a skill, it's a mindset. What I'm seeing in the reaction of Gen AI, especially from a negative or fear perspective, is the same reaction that was covered in the 70s when universities professors found out that their students had pocket calculators. And they started freaking out and going to the news and saying they can't have calculators because they can't think, they can't. But what we've done is scaled our intelligence and have privatized airspace travel and been able to do much more than we could have ever done 10 years prior to that. And that's what Gen AI is going to do for us. And eventually, we're going to be using reinforcement learning to use Gen AI to do even more things for us. And so you just need to scale up with it. And so another thing I mentioned to people is that AI doesn't stand for artificial intelligence. It stands for augmented intelligence. So if we can make this term cool, awesome. But ultimately, humans are going to have the insights, humans are going to have the improvisation, and humans are going to be the ones that kind of come up with these solutions to counter it. And then to bring it full circle from my first quote in the beginning, the best way to predict the future is to invent it. So we might as well get to building. All right. And thank you. So questions, concerns, anomalies, jokes. Yes, sir.
So my question is, I definitely see where that quantum computing will aid in development of
Quantum computing, the best way to think about quantum computing is more of a platform for computation. So the answer would be intrinsically yes, in the same way that you would use traditional GPUs now to help with digital immune systems. What's special about quantum computing in that you triggered a very nerdy thing for me, so I'm going to respond to that. What I'm so excited about quantum computing is that it allows you to compute, instead of using electricity, you're at the quantum level of computation. So you can actually compute way more exponentially than you could before. So a perfect example of that is in the medical field. Quantum computing is really going to be disruptive because a lot of the structures and biomes of DNA, especially when you want to generate pharmaceutical chemicals or medication, it's hard to do that with traditional machine learning today. It takes too much power. There's too much information that needs to be processed. So there's limitations in figuring out if a human takes this pill, what are the side effects? What's going to happen? Instead, they have to gather 200 humans together, have half take the pill, half not take the pill, and see what happens. Quantum computing is going to completely remove that from the equation because it can handle that computational power. So in that respect, the scale, it's going to help from that perspective. The architecture, the design of the solutions are going to still be human driven. That make sense? A little bit of a rant? No, it's fine, right? Awesome. Go ahead.
Thank you so much for your talk, and it's amazing. And I have a question regarding the implementation of the RL, because for myself, especially not for everybody else, is I'm writing a blog actually on the reinforcement learning and on policy and all that, etc. So I think my question is more general to that. So what kind of direction for people are deployed? For example, essentially you're training or there's so many choices.
Yeah.
In the market.
Sure.
So which one would you recommend?
Are you talking about like open source libraries or tools?
I know
Yeah.
and all those kind of.
I'm biased. We're using one from Google called Python, which has done really, really well. It's a segment off of TensorFlow that's available if you Google it now. And really, it's what we use for most of our applications, specifically because it's just very easy to use. One of the challenges when using reinforcement learning or any of this machine learning, especially when you're talking with business stakeholders, is explainability and how it actually gets to its result set and explaining that from that perspective. And so what we try to use is tools that allow us to visualize its thinking. So we can jump that in throw that into a Jupyter notebook and present it very clearly to an executive from that perspective. Yeah.
Like LLM generation and the environment access control and directive actors, basically like one solution, or you have
No. Yeah, it's going to be an orchestration of several models working together. So each box that I had in that visual, can I show the visual again? Okay, let me see if I can. You're referring to this here, right? Yeah. So, I mean, for us, the way that we thought through it there's a more complicated diagram that I can actually show you when we get off. But a lot of these solutions are even different types of solutions, whether they're public, or whether they're like, let's say, I don't know, Midjourney versus DALL-E versus something that we generate locally. It doesn't matter. The idea is to have all three of them available. The reinforcement learning decides which tool is best for what. So you see that the scale changes and they figure out the manipulation. So for example, it'll figure out that humans like Dolly images better because they're a little bit clean cut and more corporate versus Mid-Journey a little bit more epic looking. And so that'll sell to a different audience and it'll figure that out and then use the right imagery. The best example is in a use case we did with a client. They wanted to figure out, they came to us with the question of, I have to create fertilizer. I sell it on Home Depot, Lowe's, and Walmart. How do I know how much fertilizer do I have to manufacture for 12 months? And so instead of trying to figure out the manufacturing process and looking at their history to try to predict the future, which is a lot of, licking the finger and Excel spreadsheets, we went to the point of sale system that says, how much are you actually selling, and see if we can predict that. And we started to figure out drivers for that. And so what we found out is, and this is going to sound like a dumb moment, but precipitation was the best lever or business driver to figure out how much soil you would sell. Once we start to get really accurate with that, then we started using Gen AI with reinforcement learning to automatically buy ad spends so we can better influence our predictions, so we can even get more accurate with our predictions. So when we were at maybe 10, like 2-digit numbers, so we were like 15 units left, 12 units, we got down to single-digit unit numbers. We can say, okay, in this zip code and all these stores, you're going to sell and you're going to be around 3 or 4 units left over. And the point with reinforcement learning is that it's not trying to sell out. In retail, if anyone knows this, you never want to sell out and you never want to have too much inventory. You just want to have enough so people come. And so it'll figure that algorithm best. Sure, no problem.
Thank you.
There's typically an on button. Test. Here, just.
Thank you, Charles.
Thank you.
Perfect timing. Great delivery, great insight. So thanks very much. Now we're going to turn to the next session. And the person I'm going to introduce is actually the perfect definition of a polymath. Who do you know who's got a degree in astrophysical science, plus another degree in neuroscience, who's been at the Goddard Space Center, then has taught philosophy, and is now the head of the AI Center and a professor here. Michael Manino.
That's right. I run this place. You're welcome. Let me set up here for. Yeah, let me just do the. Yeah, Zoom's on. I'll close while I set up. Oh, you can do that. Okay. All right. Thank you for hanging around. No, I didn't. Yeah, I'm in. Yeah. No, you screenshot it. Yeah. This one. Oh, let me share my. Yeah. Okay. Now let me get rid of this thing here. Hide loading panel. Okay. Okay. All right, Yuda, thank you so much for the introduction. And by the way, I find it, so now for something a little bit different. I'm happy to talk to you about my expertise at the intersection of neuroscience, as Yuda mentioned, and artificial intelligence. Let me see if I got this right here. Okay. And Yuda, I like that you have brains as your, this is a perfect thing. Okay, so that's pretty cool. All right. Okay, so let's get rolling here. Okay. So it's a perfect follow-up to a lot of the talks that we heard today, because a lot of things were mentioned, which I'll sort of bring up again. Charles, you mentioned some really interesting things that I like to not rehash, but just re-mention. And I want to sort of split this short talk into 3 themes. And the first thing we'll talk about is how AI influences neuroscience. And I want to talk to you about decoding the brain with artificial intelligence and machine learning, and sort of what that means for security, for our freedoms, for our mental liberties, and things like that. So we'll talk about AI decoding the brain signals. And then we'll sort of go the other direction. The other direction is how neuroscience is influencing AI. And these are not the only ways to think about these 2 topics and the intersection of these 2 topics, but I think it's interesting. So we'll talk about I'll compare, if you will, human intelligence or HI versus artificial intelligence. And things like consciousness were mentioned earlier today. So I want to talk to you a little bit about what not only artificial intelligence means for our security in terms of our neural data, but artificial consciousness as something different, okay? And Charles, you mentioned, and several people mentioned earlier today, artificial general intelligence, the distinction between narrow AI and AGI, and then artificial superintelligence. So my point is, I don't think you can talk about those things without talking about neuroscience and how we understand the brain and cognitive neuroscience. So I think that's a very important and relevant connection there. And I would be remiss if I didn't mention a lot of the ethical considerations. So I'll just mention some of these topics: privacy, data security, equality and responsibility, and accountability. Okay, so with that, let's get started. Okay. Of course, you all know this company, and fascinatingly, just yesterday, Neuralink is announced they are actually recruiting subjects for the first human trials of its brain-computer interface, and they're looking at quadriplegic patients, actually. The reason why I bring this up, and I think it's important, is because one of the biggest points that I want to make here is that the most objective information we can have about ourselves and our own privacy is what's going on here at the level of your brain. That's the most objective metric or quantification if you have that kind of data about yourself, your wishes, your desires, your concerns, your privacy, your neural data is the end of the line, right? That's, I think, the most objective. So we talk about privacy in terms of that. This is and you're asking a neuroscientist here, I will tell you that I think a lot of what's going on with Neuralink is, let's just say, more neuro hype than realism. But that's just my own personal opinion. We can, by the way, you can ask questions during the talk, just like Charles did. That format is fine. So we talk about the threats of narrow AI and brain surveillance. Mark talked a little bit about the distinction between liberty and security. And I love this quote by one of my heroes, Benjamin Franklin. Those of you who give up essential liberty and purchase a little temporary safety deserve neither liberty nor safety. So San Francisco is the first US city to ban facial recognition. This came out in 2019. I want you to think about, and I just want to sort of raise the question here because there's not enough time to really answer it, and I don't even have a full answer for it. But what does this quote, Benjamin Franklin, which I think is one of the greatest scientists of all time, mean in terms of artificial intelligence? And as what's your name again? David mentioned in his first talk, this technology is fundamentally different in many ways. It's qualitatively, it's a paradigm shift in previous kinds of technologies. So let's talk about decoding the brain with AI. So now some fun stuff. So the more empirical stuff, then I'll get to the conceptual, abstract consciousness stuff in the second half of the talk, as I said. And what I mean here is understanding the specific and nuanced patterns of neural activity with machine learning. What can we get at with the brain, with neural data, with artificial intelligence? And it turns out some really scary, but also really cool stuff, okay? The way we measure these different brain signals, I'll just cover this really briefly. We stick people in scanners called fMRI scanners, read their blood flow, which is indicative of neurons firing in their brain. This is really good spatial resolution, so we know where things in the brain happen, but not so much when they happen. One of the other main methods is EEG, electroencephalography. So this is putting EEG caps on people and literally measuring their brain waves, alpha, beta, gamma, theta brain waves. Really good time resolution, but we don't know exactly where things are happening. So what can we get with this kinds of neural data with artificial intelligence? One of the coolest things, I think, to come online, literally, is this idea of brain reconstruction, okay? So what scientists have done is we'll have people look at a set of faces, these 5 faces, which I think were actually generated by AI. And then we'll put them in scanners, have them look at this, and there's visual information back in your visual cortex here, these neurons firing. Machine learning can actually decode those firing patterns and then reconstruct what the people are looking at without knowing what the people are actually looking at. And you can see there is some, it's pretty good. It's pretty good. This person's smiling, this person's not smiling. So this is just AI reading the brain signals. The next thing I'm going to show you is really cool. So on the left side, you'll see a person watching a movie clip. And on the right side, you'll see what the reconstruction of that is just from reading the brain signal. Okay, so here's the movie clip, and here's the clip reconstructed from brain activity. Can you get rid of that? How did I do that? Oh, thank you. So, thank you. You can see it's pretty crude, but it's getting it pretty right. Okay, so they're just watching the brain. The people are just watching that, and you can see that just from reading the neural activity in the back of the brain, we can actually reconstruct the movie that the person is watching. Scientists have already, and you may have heard this, but scientists have already have a proof of concept where you literally put people in the fMRI scanners, they go to sleep and dream, and we could play the dreams on a video. So we think about like what security means in terms of your own thinking and your own thoughts. Who would want their dreams to? I think it would be pretty cool. And you'll eventually, it's actually a study just came out 2 weeks ago with using stable diffusion that you don't even have to put people in these huge brain scanners or put like 64, 128 channel EEG caps on. We can do this with consumer devices that are out there on the market, like the Muse, for example. So imagine you get a Muse or you get a Focuscom for a couple $100. You have an app that can actually replay crudely on your phone what you dreamt last night on a video in a format. So that's coming very soon. Here's another example using generative AI. So these images on the top are the images that people were watching. Then using text to image, but like neural data to text and then text to image. And these Gen AI reproduced the visual images from what the people were actually looking at. So you can see there, it's crude, but it's pretty accurate. This study made CNN, Anderson Cooper just, I think, or I forget who it was actually reported on this. So it was all the way in CNN. Scientists were using GPT-1, a precursor of GPT-4, to passively read people's thoughts in a breakthrough. What they did here was they put people in scanners for 16 hours, they read their brain waves, and then they were looking at stories, like narratives. And then they also imagined their own story. They were told to imagine their own story. And the AI was able to get, in certain cases, the exact phrasing, but mostly it got the gist of what of the story that the person was actually looking at or reading. So the meaning, the sort of the semantic, the concepts, the gist of the story. So you can see here, the actual stimulus was, I don't have my driver's license yet, and I just jumped right when I needed to. And she says, well, why don't you come back to my house and I'll give you a ride? I say, okay. She is not ready. She has not even started to learn to drive yet. I had to push her out of the car. I said, we will take her home now. And she agreed. So you have exact phrasing, the gist, and then the errors as well. So in other words, it wasn't only reading the brain signals, it was then using generative AI to constrain the output so that you can actually get the gist of the story that the person was either reading or just imagining. So really, really cool stuff. Now, in this particular case, you had to scan people's brains for 16 hours. And if I don't scan your brain, because there's a personalized component to all this, then I can't, and the system will break, right? So you have to train the model in the particular brain, which takes a lot of energy. This is a brain-computer interface, which I'm sure many of you have seen. Here we have a woman actually just thinking to move her arm and take a drink. And so that's using machine learning. AI-driven algorithms can detect what are called brain fingerprints. So each of us have a unique thumbprint. We also have a brain fingerprint, and machine learning can actually detect that. And it's so accurate that you can actually predict with 99% accuracy a person's IQ based on knowing their brain fingerprint. You can actually detect autism and things like that as well. AI can decode brain signals to allow paralyzed people to handwrite. So if I go A, B, C, and I don't move my arm, I just think about moving my arm in that way, the AI can actually decode that and write out A, B, C, D. Deep learning can actually be used to recognize depression in speech, because we have certain phrases that we use, tonality, prosody. There's all these things that the human brain cannot recognize that deep learning can, that are indicative of when a person is actually clinically depressed. Convolutional neural network was using, can diagnose mild cognitive impairment. I'll just read off some of these for you here. Artificial intelligence can predict brain age, your actual brain age, just from your EEG signals. Can help people with autism to read emotions, predict dementia now. This was really fascinating. This came out just a couple months ago. AI can now detect early stage Parkinson's disease just from your breathing patterns. So you go to sleep, you put on a strap, you breathe throughout the night, and AI can detect that. Paul Zak came out with this study a few weeks ago. Machine learning can now predict whether a song will be a hit with 97% accuracy just by reading the neural activity of when you're listening to that song. So this is something called neuro forecasting. We can actually predict with 97% accuracy whether a song will be a smash hit just from reading the neural activity in your brain from when you're actually listening to that song. So in other words, whether a song will be a hit is in our brains, right? Ultimately, it comes back to in our brains. Our behaviors are other things too, but also our brains. So if we can actually detect and decode those kinds of signals, we can predict when a song will be a hit. Pretty crazy. Machine learning reveals brain networks involved in child aggression as well. So with that, it brings up all of these questions about responsible AI and these ethical considerations. I won't cover all of these here, but there's a lot, right? Privacy, I think our notions of privacy will have to change based on AI decoding brain signals, and especially using generative AI as well. Over-reliance on AI for diagnosis. In fact, a company just came online called iBerry. They secured, I think, $8 million in seed funding. Just using natural language processing and computer vision can now detect suicidal ideation just in a 5 or 10 minute conversation. Anxiety, depression, things like that. This company, VUCA, is using generative AI in cognitive behavioral therapeutic context. So it's using CBT as a personal therapist, and it's working. It's pretty incredible. Having said all that, what are the risks posed by this idea of AI decoding brain data and getting at our most personal information, which is the point that I'm trying to make here? What are the potential misuses of brain-computer interfaces? I'm doing some research on this as well, but Nita Farahani out of Duke University just published a book, which I would highly recommend, called The Battle for Your Brain: Defending the Right to Think Freely in the Age of Neurotechnology. And again, now that these consumer devices are coming out, you can buy them for a couple $100. It's going to become more ubiquitous that all of our neural signals are going to get out there in the world. Okay. It's not just you have to put people in scanners and put huge, expensive $18,000 caps on their head. It's going to be very scalable and consumer friendly. So moving into the second half now of my talk, my question is, can we still be what I consider myself a techno optimist? Okay. Can we still be a techno optimist? And I think we can, given all that concern and uncertainty that I just talked about. I think AI will save the world. I think a lot of these amazing things that AI can do with our neural data are very interesting, but you have all of these proclamations, right? Artificial intelligence can lead to extinction. You've seen this. Jeffrey Hinton leaves. We paused giant AI experiments, right? Because as David was saying, the pace at which this technology is increasing itself, and that seriously outpaces the slowness of government regulation. And all my science fiction fans out there, Charles, I'm looking at you. Dune, universe, banned AI. Should we? Even the CSO, the chief science officer, I believe, of OpenAI said it may be that today's large neural networks are slightly conscious. Wow. That was mind-blowing when I saw that. And to all of my neuroscientist colleagues across the world, I am in stark disagreement with that as a neuroscientist, but we can get into that if you have any questions. So it brings up this question: is artificial consciousness possible? We have artificial intelligence, and when these things become more and more and more and more intelligent, there's this idea, this mistake, I think, that a lot of people like Isla make, that they equate or conflate intelligence with consciousness. The idea is that as these machines become more and more and more intelligent, at one point, the lights come on they become sentient, they become self-aware. That's what consciousness is, right? It's the colors that we see, it's the emotions and internal sensations that we get. It's an awareness. It's a qualitative sense. We all know it, right? It goes offline. How many people have been under anesthesia, general anesthesia for surgery? That's what goes away. When you wake up, consciousness comes back, right? When we're in deep sleep, consciousness goes away. So we all know this idea of self-awareness. Can machines be conscious, right? That's sort of what we're talking about here. My close friend and colleague, Anil Seth, who's the director of the Sackler Center for Consciousness in the UK, wrote recently a great article, which I highly recommend you read, called Why Conscious AI is a Bad Idea. He and I and many neuroscientists do not think that conscious AI is possible in principle, let alone in practice. Or I should say in practice, let alone in principle, for several reasons. One is this idea that people, as I said, conflate intelligence with consciousness. And there's no reason to believe from a neuroscientific perspective that as things become more and more intelligent, they'll suddenly become conscious. Having said that, he, myself, and other neuroscientists have signed a letter that we do agree that we should really take very big concerns and the precautionary principle, right? That we should not try to actually develop conscious AI as it stands right now. That we should definitely put a pause. And there are people already trying to do this, and not only making statements like the chief science officer of OpenAI, but trying to develop conscious artificial consciousness. So what does that look like? What would it even look like? How would we know? And this is where I'm going to, Charles, bring up my AlphaGo example as well. Here, I want to talk to you just to give you a little bit of an indication here. What is the difference between human intelligence and artificial intelligence? Because I don't think a lot of people actually know that, right? At least explicitly, even the chief science officer of OpenAI. But this is, of course, DeepMind beat Garry Kasparov, the world's greatest chess player at that time, based on these patterns and predictions. Of course, next came the semantic part of this, right? IBM Watson won Jeopardy. So understanding the nuances of language and equivocation and semantics. And then, of course, the AlphaGo example. Now, what Charles didn't mention, was, it's very well known, maybe some of you know this, but game 2, move 37. Should look it up. Move 37 of game 2, AlphaGo made a move that completely stunned Lee Sedol and the rest of the world. And it was sort of indicative, probably, of what? Exactly. And creativity. And so that is really interesting, right? So that was a little scary, but also, quite compelling and interesting. So what's the difference? How would we know between whether artificial intelligence is conscious, whether it can be creative, whether it can be compassionate or empathetic? By the way, there's if you don't know of a HeyPi, how many people know of HeyPi, the LLM HeyPi? Yeah, so you could try that too. It's a more empathic, kinder, gentler, compassionate ChatGPT, essentially. Exactly, personal intelligence. A study just came out a few months ago that infants outperform AI in common sense, or what's called folk psychology. So infants can actually, we humans have what's called a theory of mind. I understand that you're all listening to me now. I see your head nodding, things like that. I know you understand what I'm saying. You're interested, I could tell, or at least most of you. Some of you are, right. That's called a theory of mind. I understand that you have desires, wishes, things like that. Babies outperform these artificial neural networks in understanding the motivation behind people better than the ANNs. So that's really, that's just fascinating to me. Human intelligence versus AI, complex decision making. Mark talked about a little bit about VUCA, volatility, uncertainty, complexity, and ambiguity when he was talking about flexibility. So we can make decisions in VUCA. We generalize, we transfer our learning, we move from one domain to the other. We have emotions and empathy, which significantly contributes to our decision-making. Creativity and innovation. Of course, human intelligence has limitations as well. We are subject to cognitive biases, speed of processing information, emotional interference. Narrow AI, very good at identifying patterns far beyond human capabilities, right? Like recognizing Parkinson's disease. Speed and efficiency, it's much better. Consistency, consistent performance given the same input, right? You'll get the same output, but remember, it's still garbage in, garbage out. As we all, I see a lot of head nodding out there. AI is still garbage in, garbage out. Limitations, lacks context, common sense reasoning, empathy. And of course, it depends, as I just said, or indicated, on the quality and the quantity of data it was trained on, and it still can perpetuate biases present in the data. So now a little bit about the brain, and then we'll get into how I want to finish my talk. This is a picture of the human brain, the most complex system of which we know. This is actually my brain. You can see all the holes if you look closely. No, I'm just kidding. 86 billion neurons, many more glial cells, 125 trillion connections. I just wanted to get you to understand the difference between what, you know, these chips out there, these models out there, and the complexity. We don't even need complexity science yet to actually understand how artificial intelligence works, I don't think, but we do need it. We need complex adaptive systems to understand the brain. You know, the brain was traditionally parcellated into like the visual cortex, temporal lobes, the frontal lobe and the parietal lobe, these sort of four traditional lobes of the brain. We now know that the brain can be parcellated into like hundreds of different cytoarchitectonic structures that can all talk to one another in very dynamic ways. I'm going to show you a really cool visualization of how that works. Even just the outer 2 millimeters of the human brain, this right here, just the gray matter. So there's the white matter, right? And then, you know, the corpus callosum connecting the two hemispheres. There's the cerebellum, which you could see is kind of weaker from all the whiskey that I like. Just kidding. But even this gray matter, this 2 millimeters, is separated into 6 different cortical layers, and that's like a little bit of a picture of what it actually looks like. It's an amazingly complex system. So we think about what ANNs look like from 1980s and moving up with deep learning models from 2000s. It's a black box, but you know, this is also, I'm trying to say, a black box. So understanding what's going on in the hidden layers and how these sort of things work is enormously, I think, it's not simple, but it's simpler than understanding the complexity of the human brain. These two guys won the Nobel Prize back in 1950s. This is Hubel and Wiesel. They actually designed the first computational model of a neuron. This is what I used in my research, actually. And it's just a set of differential equations. All the way up to now, this massively failed project. This project failed massively. This is the Human Brain Project in the EU, using massive supercomputers to try and simulate consciousness, or to simulate cognition or cognitive processes like learning, like working memory, like perception, like language use. Nevertheless, AI is helping scientists to explain our brain. But let me just give you a brief argument of why that won't work, okay? And this right here is, I'm drawing the line between the difference between artificial intelligence and why I think AGI is not possible in practice and in principle, versus you know, what we know from cognitive neuroscience. So first of all, the human brain is robust, right? I can sever your two hemispheres and you could still live quite well, actually. Whereas if I stick a pencil in a CPU or a GPU, right, not going to work, right? So it's enormously robust, the human brain. It's enormously efficient, right? We know this, 24 million watts versus just the 20 watts that the human brain runs on. Think about a supercomputer. The connectivity is incredible. So we think about the connectivity of you know, artificial intelligence, even like model connectivity versus hardware connectivity, but also the connectivity of the brain is enormously complex. And neuroplasticity. our brains are plastic, right? They change in response to external stimuli and internal stimuli as well. This is a beautiful, beautiful thing that evolution has bequeathed us with. Okay, so let me finish up. Having said that, we do have a storage capacity. The brain storage capacity is about 2.5 petabytes. It's estimated, okay? So I'll leave you with this beautiful, beautiful visualization, computational visualization of a human brain playing a game in virtual reality in real time. This is Adam Ghazali, my colleague at USCF. This is called the glass brain. This is his brain. And you could just see all the colors lighting up. These are the different brain waves like alpha, beta, gamma, and delta. And the neurons are firing in response to stimuli from the virtual reality. And you kind of do a fly through his brain, and you could just see the beauty and the complexity of what's going on in the brain that produces things like cognition and ultimately consciousness. So having said all that, this conference in cybersecurity, going back to Nita Farahani and the battle for your brain and this most objective personal data that we have, she says, we must establish the right to cognitive liberty. I love that phrase, cognitive liberty, to protect our freedom of thought and rumination, our mental privacy, and self-determination over our brains and mental experiences. I think it's a really huge concern, and people are looking into this, and it's a scary thing, but also a very, again, I think an optimistic thing as well. So I'll leave that. Thank you. Questions?
Thank you, Mike.
Concerns?
I think there's a
Yeah.
question there.
Avi.
Being a disabled veteran of the Israeli army, I was always concerned about it, and I was wondering if you saw the 60 Minutes about implanting electrodes connecting a disabled person's brain to his artificial hand and controlling it by thought. I feel that this is where we are going for integration of AI and human brain.
Yeah.
And what do you think about this potential?
Yeah, I think there's enormous potential in that, and this idea of human-centric AI. I think actually, I agree with you. I think you hit the nail on the head, Avi. I think if you can hear me, I think that oh, it is working. Okay, good. That the whole idea of conscious AI is probably going to be a moot point because of the integration, non-invasive, let's just say, because there's Neuralink, but non-invasive integration of artificial intelligence, reading all of our data, making recommendations for us, personalizing, optimizing, detecting, all of those things. So
this
yeah.
60 Minutes showed an invasive. They actually cut an electrode and connected it to the brain, and he was thinking about the movement.
Yeah.
And his fingers were the artificial hand was moving the fingers.
Yeah, it's incredible. It's absolutely incredible. Eventually we'll be able to do that with artificial intelligence non-invasively. We're already doing that. So yeah, correct. Thanks, Avi. Yeah. David. Oh yeah, go ahead. You want to one more question? I know. I'm sure I want the hard ones. Give me the hard ones.
So, for instance, you believe that AGI is not practical or in principle possible.
Right. I think yes. Yes.
So let me ask you this question. I'm going to agree with you that elements of consciousness.
Okay.
The question I want to ask you is:
Does it follow from that?
Is consciousness required for artificial general intelligence in your mind?
I don't think it's a necessary. I think it's a necessary but not sufficient condition to be a little bit more nuanced in my argument for artificial general intelligence. My point is that I think conscious AI is something altogether different, because then it has values. It has, we might be obligated to take care of it, right? To concern for it. It wasn't that as Anil said, Frankenstein's creature came to life. It's that it could feel.
Yeah. So
ask you that. Do you think brain violates laws of physics?
No, absolutely not. I think but I don't think the laws of physics are up to the task of explaining the brain. I think you need to go beyond. I think it's not only physics. I think you need complexity science, and other fields to come into play to explain the human brain. Possibly. Look, I don't think this is the only possible thing that could instantiate consciousness. So you're what's called I think your argument is what's called a functionalist, right? However, I do think that this is an embodied thing. It's living flesh tissue. There's this notion of embodied cognition or embodied consciousness. And I think that, you have things like robotics and embodied artificial intelligence, right? But I think that also is a necessary condition for consciousness. Let's just say an embodiment, right? A coupling to its environment to actually move around and feel things and shape the world to our the way we move. Okay. So that was the final argument in the argument I was giving about
We'll
neuroplasticity.
take one more question there, and then we'll move to the next session, and then we can all stay later.
We can geek out.
Geek out as much as we'd like. Please go ahead.
It can be quantified.
If AI manipulating or becoming, AGI is possible through quantitative plotting of human feelings and psychology as conditions, then what is the difference between it? What's the difference? Because if it can learn, if it understands what love is, if it can understand what creativity is, if it can learn all of these things, then what is the defining factor that separates it from consciousness?
That's a great question. It might not even be necessary for AI to be conscious for us to, there's do you know the Turing test? So there's a reframe of the Turing test called the Garland test from the movie Ex Machina, where AI gives this cognitive illusion. So in other words, just like visual illusions, like you can look at the visual illusion and your brain still gets fooled, even though you know that it's an illusion and how it works. You cannot get beyond that, right? Your visual cortex cannot get beyond the illusion, even though cognitively you know how it works. Same thing might happen with artificial intelligence, right? We can, it might not need to actually experience consciousness or love or empathy or those kinds of things, but it might just be an illusion. But it presents to us this cognitive illusion, and that could have also interesting consequences for religions, for the way we interact with it, for our mental health, all of those kinds of things. So that also is a real concern, like Hey Pi, for example, right? Or these companies that are coming online that are using cognitive behavioral therapy to actually not get you to commit suicide because you think that it understands you. So there are real positive benefits out there, but that presents major concerns. So I don't have it's a hand wavy answer to, I don't know the difference, but there might not need even to be a difference. I was saying that there is, but there might not need to be. Okay. Yep. Yeah. Yeah. What is the development or the future of AI in neurodevelopmental disorders? Yeah, I even presented one of those studies. I went over it briefly that emotion reading AI assistants can now assist people with autism who are non-neurotypical. So I think the future of I don't want to say making atypical people neurotypical. I don't want to go there. But I think that there's enormous potential. I can give you tons of examples of artificial intelligence alleviating helping people with autism or who are on the spectrum or with schizophrenia. It's a good thing. Yeah. Thank you very much.
Thank you very much, Michael. And I just love the parallels and the mutual reinforcement between the two. And hopefully we'll find out who is right between. It's not a matter of right. It's still a matter of intellectual engagement and enjoyment. So with that, we're going to move into our last session. It is a panel, and I'm going to welcome 3 new participants here. One of them is